there's a cold and mysterious region known as the Oort cloud. It's a hypothetical vast area of icy space objects surrounding the Sun. It's believed to lie far, far away from our star, from 2,000 to 5,000 astronomical units. For comparison, Pluto's orbit carries the planet between 30 and 50 astronomical units from the Sun. And there, in this freezing emptiness, a rogue planet may be hiding right at the moment. At least, that's what new research has recently suggested. Rogue planets are called this way because they don't orbit around any star. They wander the galaxy alone, totally untethered. Without stars, they don't have days or nights, only eternal darkness. Rogue planets are usually kicked out of their planetary systems, doomed to a solitary existence of circling the center of the galaxy on their own. Of the thousands of planets scientists have detected outside of our solar system, only a dozen or so are starless and cruising on their own. At the same time, there might be billions or even trillions of rogue planets wandering around our galaxy. If these estimations are true, it might mean that the Milky Way contains more free-floating planets than stars. Anyway, in 1907, one astronomer started a search for Planet X. It's a hypothetical giant planet moving around the Sun beyond the orbit of Neptune. The scientist was convinced that this planet existed because he had observed some irregularities in the orbits of Uranus and Neptune. His idea led to the discovery of Pluto in 1930. But the dwarf planet was too small to have any serious gravitational impact on the orbit of Neptune, let alone Uranus. These days, the Planet X theory is largely considered to be discredited, but it hasn't stopped astronomers from searching for planets in the far reaches of our solar system. And shockingly, a new study claims there might be one or even more out there, but much, much further away than predicted. An international team of scientists has recently simulated the unstable celestial mechanisms of the early solar system. They've discovered that there's a possibility that a few planet-sized bodies might have come to rest in the Oort cloud. You see, about 4.5 billion years ago, when the solar system was just forming, it was a hectic and unsettled place. Gravity sent debris from the cooling protoplanetary dust cloud hurtling around like cosmic tennis balls. From time to time, large chunks of this debris, even planet-sized ones, were sent flying far enough to escape the Sun's gravity altogether. Such pieces of debris turned into rogue planets. Researchers have seen such space wanderers in distant exoplanetary systems, but according to them, there's a 0.5% chance that one or more of those wayward planets formed in the solar system and ended up in the Oort cloud after drifting away from the Sun. At the same time, it's slightly more likely that a rogue, Neptune-like planet was snagged by the Sun's gravity from another planetary system. And then, this planet came to rest somewhere in the Oort cloud. The chances that this scenario is true reach 7%. If this turns out to be the case, then a space body similar to Planet X might indeed be hiding out there, on the outskirts of our solar system. The only problem is that it would still be too far away to have any impact on Neptune's orbit. In any case, most researchers are convinced that the Oort cloud is made up of a collection of way smaller icy objects. But given the distance to the Oort cloud and its enormous size, we may never really figure out what is lurking out there.
For thousands of years, people knew only about the planets Mercury, Venus, Mars, Jupiter, and Saturn, which they could see using simple telescopes, or even by the naked eye if conditions were good. But in the late 18th century, a famous astronomer named Sir William Herschel discovered a new planet that was icy blue in color. At first, people thought it was a star, but later they realized it was a planet. Today, we know it as Uranus, a planet that's more than 19 times farther away from the Sun than Earth. It's so far away that it takes Uranus 84 years to complete one trip around the Sun. This astronomer also discovered many other interesting things in space, like double stars and nebulae. In the mid-1800s, scientists noticed something pulled Uranus and strangely tugged its orbit. They thought there must be another planet out there, and they used math to predict where it would be. Finally, in 1846, they found Neptune using a telescope. It was too faint to see with the naked eye because it was too far away from the Sun. It was all so exciting. Who knows how many other planets could be there, lurking in the darkness of our solar system? Back in the mid-1800s, astronomers noticed something unusual was happening in the sky. A small rocky planet named Mercury was behaving strangely. It didn't follow the predictable orbit that was expected of it. One of the astronomers was a brilliant French scientist named Urbain Le Verrier. He came up with a theory that there could be another planet in our solar system no one had yet discovered. It would be located somewhere between Mercury and the Sun. This hypothetical planet, which he named Vulcan after the Roman god of fire, would have an incredibly hot surface, and it could be a potential explanation for Mercury's strange behavior. He never surely claimed Vulcan was really the one thing disturbing the orbit of Mercury. But, excited by the possibility of discovering a new planet, astronomers all over the world took the idea of Vulcan. For a planet that didn't exist, people committed to developing ideas and getting information about it. Some scientists didn't think it was likely that they had missed another planet as big as Mercury. It would have been hard not to see it by then. But there was a tiny chance of a smaller planet existing inside Mercury's orbit that was too close to the Sun, so no one could see it. One theory said it was about 13 million miles away from the Sun. Mercury is the planet with the most eccentric orbit in our solar system, but the closest point it gets to the Sun is about 28.5 million miles. This means Vulcan would be under half of that distance. The theory moved on, saying that if Vulcan existed, it would orbit the Sun every 19 days and 18 hours, and its path would be tilted about 12 degrees relative to the path of other planets in our solar system. Vulcan's position at its furthest point from the Sun would still be too close to the Sun to be seen with the naked eye, even during twilight. The only chance of seeing Vulcan would be during a solar eclipse, or when it passed in front of the Sun, which, as the theory said, would be 2 to 4 times a year. They had a theory that this mysterious planet was so close to the Sun that it could only be seen during a total solar eclipse when the moon blocked out the Sun's blinding glare. So, every time there was an eclipse, scientists would peer at the Sun, hoping to catch a glimpse of Vulcan. They were trying really hard, but no matter what, they couldn't find this mysterious planet. Some astronomers claimed to have spotted it during eclipses, but no one could ever confirm or find evidence for that. The theory of Vulcan was left waiting for some better times. Einstein had a different idea. You know about his theory of general relativity, right? That's where he claimed gravity wasn't some sort of natural force, but a result of space-time curved because of the presence of giant space objects, like planets and stars. Planets circle around the Sun in their usual orbit because space-time is curved. That means the planets are kind of falling towards the central star of our solar system. And Einstein tried to explain Mercury's unusual orbit using his own theory of relativity. Unlike the other planets in our solar system, Mercury's orbit wasn't that circular. Instead, it seemed to wobble slightly, as if there was an invisible force pulling it away. Einstein said this could be happening because the massive gravity of our Sun was actually curving the fabric of space-time around it. He claimed it's possible this changed Mercury's orbit a little bit. It took the scientific community a while to test this theory, but it eventually seemed like the most plausible explanation. Even though Einstein's theory gave us a more elegant explanation for Mercury's strange orbit, some scientists were still holding out hope for Vulcan. It was especially hard to let go of the idea of Vulcan because Mercury is also the planet that's really hard to see from where we're standing. But later, more and more scientists started accepting Einstein's theory above their imagination. And they would observe a total solar eclipse specifically to test Einstein's theory of relativity, not because of Vulcan. And Vulcan is not the only hypothetical planet everyone was talking about. In the newer age, some believe there could be a mysterious planet lurking in the outer part of our solar system. But this one is more likely to exist. No one has seen it directly yet, but computer simulations show this so-called Planet 9, or Planet X, is probably somewhere there beyond Neptune. Neptune and Planet X could be similar in size. Planet X could be 10 times more massive than Earth and circles around our Sun in an elongated shape, which is on average 20 times farther from the Sun than Neptune. A year there may last between 10,000 to 20,000 Earth years. By comparison, a year on Neptune lasts 165 Earth years. Something this big moving out there beyond Neptune could explain the unusual orbits of smaller objects in the Kuiper Belt. The Kuiper Belt is the area of our solar system beyond Neptune and where it orbits. And there are most likely many asteroids, comets, and some other smaller bodies there, mostly made of ice. There was another hypothetical planet called Nibiru. Remember those rumors that the world could end back in 2012? One of the popular scenarios was Nibiru, which some claimed would hit our home planet at the end of the year. Of course, nothing happened. We're still here, all set and good, but the idea of Nibiru seemed interesting. Stories started in the 1970s when a man named Zecharia Sitchin mentioned Nibiru in his book, The 12th Planet, claiming it orbits the Sun every 3,600 years. But there's no chance a planet with such an eccentric orbit wouldn't disrupt other planets in our solar system with its gravity. And if it was really coming that close to Earth in 2012, we were supposed to be able to see it with the naked eye. Some simple calculations showed Nibiru would have been nearly as bright as Mars at its dimmest and brighter than the faintest stars you see from a city. Oh well, maybe we'll have more luck in the next 3,500 and something years. In 2011, a comet named Elenin appeared that many people thought could be Nibiru. But when you're looking at comets and planets through a telescope, you see they appear differently. A comet has a coma, which is a gas atmosphere, together with a tail, something a planet doesn't have. Plus, this comet didn't slam into the Earth. It came too close to our Sun and fell apart. The leftover pieces will continue moving on their way to the outer solar system for the next 12,000 years.
Dark, mysterious, cold space. Comets, asteroids, planets, stars, and something that's lurking over there, far beyond Pluto. Yup, this could be the 9th planet of our solar system, the one people have been wondering about for centuries. IRAS, which stands for the Infrared Astronomical Satellite, collected interesting data back in 1983. It could be proof that Planet 9 is hiding there. No one knows if it really exists, but this discovery helped to build a model to understand this potential planet better. And in 2016, scientists found out that some small space objects in the Kuiper Belt were orbiting a bit oddly. The Kuiper Belt is the outer area of our solar system. It's a ring in the shape of a donut, filled with leftovers from the times when our solar system was forming. You can find this donut beyond Neptune. The objects in that region of space have weird orbits, almost as if a big body with strong gravity is pushing them away. Knock knock, Planet 9 again. The theory says it might be 5 to 10 times the mass of our own planet and up to 20 times further away than Neptune. The astronomical unit equals the distance between our planet and the Sun. Pluto is approximately 40 astronomical units from the Sun, but Planet 9, if it exists, is 400 to 800 astronomical units away. It would take 10,000 to 20,000 Earth years for this mysterious planet to make a single circle around the Sun. This makes it harder for us to catch this space body. There's a theory Planet 9 may have formed between the orbits of Jupiter and Neptune, similar to the rest of the gas giants in our solar system. The gravitational force of one of the two huge planets probably kicked it out of its orbit. Oh no. Then Planet 9 could get ejected further away from the 8 planets we know about. It ended up as some sort of icy waste, quite small at the beginning. But as time went by, Planet 9 has cleared its orbit of frozen pieces of rock and dust and finally formed into a real planet. Another theory says that this could be a planet another star lost on its way while it was passing near our solar system. In any case, Planet 9 probably doesn't reflect that much sunlight since it's so far away, and astronomers aren't sure where exactly they should look for it. Space is dark, mysterious, endless, obviously. But if we do find Planet 9, it will be the first solid proof there are more planets in our solar system than we thought. Moving on to an interesting exoplanet, located only 90 light-years away from us. An exoplanet is generally a planet located outside our solar system. This one has an atmosphere with water clouds. 1 year there lasts 24 Earth days, and the planet travels around a red dwarf star, which is way dimmer and smaller than our Sun. That's why, even though the planet is 8 times closer to its star than we are to our Sun, the temperature there is similar to that on our planet. This exoplanet has a size similar to Neptune. It's also less dense, which means it's mostly made of gas, unlike Earth, which is made of rock. The average temperatures there is 140 degrees, which makes it one of the coolest small exoplanets we've ever discovered. And the cooler the exoplanet is, the bigger the chance we'll find clouds in its atmosphere. Researchers have discovered more than 4,000 exoplanets, but all of them have been found within the Milky Way, at least until now. For the first time, astronomers may have spotted a planet outside our galaxy. They called it M51 ULS-1. The planet is located in the Whirlpool Galaxy, a distant spiral galaxy 28 million light-years away from us. There was once a huge but pretty young star that got stuck in a gravitational dance with something that could be a dense neutron star, the collapsed core of a giant star, or a black hole. The star's dance partner had incredibly strong gravity. It was feeding on the star, greedily ripping away its plasma. Then something unusual happened. An unknown, maybe even Saturn-sized object passed by and blocked this confrontation from our solar system. Now no one can see what is going on, but this could potentially be the farthest planet we've ever discovered. There's a newly discovered planet outside our solar system. As large as Jupiter, it orbits 2 stars, and as we can observe it from our planet, it crosses in front of them both. The full circle around these 2 stars, which means 1 year, takes approximately 200 Earth days. On the day of the discovery of the previous planet, scientists also found it had an unusual companion. It's an extra-hot Jupiter with an ultra-tight orbit around its star. The year there lasts only 1.9 Earth days. This planet has a weirdly shaped orbit. Also, it travels in the opposite direction from the rotation of its star. If you could travel 57 light-years away from our planet, you'd see something pink lurking in the darkness. As you get closer, it becomes bigger and more fascinating. Yup, it's a magenta-colored planet. A few billion miles away from its sun, this guy is one of the youngest planets scientists have discovered. It's only 100 to 200 million years old. It's made of pink gas, similar to our Jupiter. So if you could fly closer to its surface, this gas would envelop you like a thick fog. You're coming closer and going deeper, and the gas is becoming darker, getting a reddish shade. And look at the planet's core. It's super hot. Because of its high temperature of 460 degrees Fahrenheit, this planet is like an oven. The heat is the reason the planet glows so brightly. You'll also notice the sky is hazy pink, with clouds made of droplets of frozen water, similar to ours. There's another exoplanet half as massive as Earth, which is one of the smallest planets we've ever found outside our solar system. It has a diameter of 5,600 miles. For comparison, Earth's diameter is 7,900 miles. The planet in question is mostly made of iron, similar to Mercury. Mercury has a massive iron core and a very thin crust, which makes it an oddball in our solar system. At its early stages, it collided with some space body at least once. That collision pulled its outer layers away, which is why only the firm iron core remained. Maybe this exoplanet participated in a huge space crash too. That's what probably took away the planet's mantle and left mostly its iron core. Or maybe this is just a remnant of a gaseous planet that used to be the size of Neptune. The atmosphere of the planet could be blown away by, let's say, a huge amount of radiation coming from the star. This planet is only 31 light-years away from us, and the day there is less than 8 Earth hours long. The planet is only a little bit bigger than Mars. People aren't likely to ever settle in that place because of its extreme temperatures that go up to 2,700 degrees Fahrenheit. There might even be molten lava on the side of the planet that faces its star. Such temperatures are high enough to evaporate any atmosphere, so this planet might have had one in the past. Generally, gas giants like Jupiter can't support life because they have extreme weather conditions, temperature, and pressure, and there are no building blocks that might create life. But smaller terrestrial planets, such as, Earth, have more key ingredients like oxygen and liquid water. Plus, they have more temperate weather and other conditions. And still, not all of such planets support life, of course. It's not easy to find a planet with similar conditions as the ones we have on Earth, or at least the conditions that would allow life to develop there. But meet Kepler 22b, one of our most promising findings. It's 600 light-years away from us, twice bigger than our planet, and with temperatures of about 72 degrees Fahrenheit. This is a so-called super-Earth. It's a category of planets unlike any we have in the solar system. They're more massive than Earth, but still lighter than ice giants such as Uranus or Neptune. Super-Earths can consist of rock, gas, or a mixture of these two. Kepler 22b is within the habitable zone of its parent star, which is less bright than our Sun. The planet probably has a rocky core. It may have an ocean, but it doesn't host any life. At least, we don't know about it yet.
Can a planet be bigger than its parent star? Well, if you mean a star like our Sun, it's highly unlikely. But what if it was a white dwarf, the remnant of a star similar to ours that went out after shedding its outer layers and leaving behind nothing but the core? This core is what we call a white dwarf. Usually, it's around the size of our home planet. If a star had a planet bigger than Earth before it extinguished, it's possible that such a planet could survive all the chaos. In this case, a planet that is bigger than its star might actually exist. And we've even found planetary systems like this. But there's one problem. A white dwarf isn't a real star like our Sun anymore. It doesn't produce energy, just sits out there getting cooler and cooler. So probably such systems don't count. For comparison, the Sun is working non-stop. It is fusing hydrogen into helium in its core. It has been doing it for more than 4 billion years and is going to keep doing it for the next 7 or 8 billion years. The Sun is 10 times as wide as the largest planet in our solar system, gas giant Jupiter. And sadly, you can't get a planet much larger than that. If you start adding mass to such a world, it will get smaller, not bigger. So it seems you can find a planet larger than the Sun. But there are also dim red dwarf stars. They're the smallest out there, barely massive enough to maintain fusion in their cores. The tiniest stars that we know about have been discovered recently. If astronomers' conclusions are correct, then both of them can hardly fuse hydrogen into helium. And it takes about 0.077 times the Sun's mass, or 75 masses of Jupiter, to be able to do that. And still, they're real stars, just very tiny, smaller than Jupiter. One of them is only about the size of Saturn, which must mean that stars can have planets bigger than they are, right? Well, theoretically. When it comes to practice, you can hardly find such planetary systems. We've found and observed quite a lot of exoplanets, which are worlds orbiting other stars. It seems that there are indeed loads of trends out there in space, different masses, sizes, brightness, and so on. But the main trend? Red dwarfs don't usually have gas giants orbiting them. If they do have planets, those are typically small, rocky worlds, more like Earth. Those are also called terrestrial planets. For example, a red dwarf called TRAPPIST-1 has 7 Earth-sized planets orbiting it. But gas giants circling around red dwarfs are extremely rare. Hardly 1 in 100 tiny stars can boast such a planet. This number can be even smaller since the research has been done using candidate planets which haven't been confirmed yet. Plus, the smallest stars are also the dimmest. It means they are extremely hard to detect. and it's incredibly hard to figure out whether they have planets orbiting them, and if they do, whether these planets are gas giants or terrestrial worlds. Still, it's possible that a system where the planet is larger than its parent star exists. But the probability is statistically very low. At the same time, red dwarf stars are very numerous. They're actually the most common kind of star in the galaxy, making up around 70% of all stars. And even though really tiny red dwarfs are relatively rare, there still must be millions or probably even billions of them in the galaxy. And if there's even a small fraction of red dwarfs with gas giants orbiting them, it might still mean that a lot of such systems exist in total, and some of them can have planets bigger than their host star.
We've discovered Kepler-22b, a small exoplanet in the Cygnus constellation. Seems like nothing important, right? But it's actually a big deal. This is the first planet located in the habitable zone that was found by the Kepler telescope. In other words, there may be water on this planet, and if there's water, there may be life. Kepler-22b can become our new potential home. So let's take a closer look at it. Actually, discovering new planets is not easy at all. Not all of them can be seen through our super cool telescopes, even the almighty Hubble. Sometimes, the stars are so small and dim that it's really hard to find them on a map. The same thing happened with Kepler-22. In such cases, scientists have to use a special method. First, they take a bunch of photos of the star in different periods of time. Then, they look at them and think, are there any dark dots on this star somewhere? And if they find one, that might be a planet. These photos actually help us to discover some very important stuff. Like, first of all, this planet exists. Secondly, here is its size, radius, and proximity to the star. And finally, will we be able to live there? Now we know that Kepler-22b is very similar to our planet and could potentially become a second Earth. It's also very close to us, only 635 light-years away. Yeah, it's about 3 quadrillion miles, but this is one of the closest options. Kepler-22, the star of Kepler-22b, is a yellow dwarf. It's very, very similar to our Sun. The same size, the same radius, even the age is almost the same, 4 billion years. The difference is only in luminosity. It's about 20% dimmer than the Sun. So, no matter how much you strain your eyes, you won't see this star in the night sky. The planet Kepler-22b is about 2.4 times larger than our Earth, and that's pretty good. More radius means more potential water and space to live. Although going from one city to another would take a while. It's scary to even imagine a 3-day-long plane flight. We don't know the exact mass of this planet, but scientists think it's bigger than Earth's. Actually, the mass of Kepler-22b can be up to 36 times greater than that of our planet. What does it mean? Vigorous gravity. If the planet is 36 times heavier than Earth, then gravity there will be about 6 times stronger. Can you barely lift 20 pounds of potatoes? Try 120. Not to mention that you yourself can become much heavier on that planet. You'll have to get incredibly pumped up just to walk there. You have to literally turn yourself into a bodybuilder just to get to work. The worst thing is that with such gravity, it'd be incredibly difficult for plants to survive there. They'd need at least a little freedom to rise up from the ground. And animals. Our dogs and cats would have to turn into little balls of muscle to survive there. But if this planet has its own animals or other inhabitants, we can roughly imagine what they may look like. They probably have a lot of legs to make moving easier. They aren't really tall, but they're very massive and extremely strong. Muscular giant spiders? Could be worse, I guess. The good news is that this is all unconfirmed information. If we're very lucky, and gravity there turns out to be just a bit stronger than Earth's, then, of course, it'll be much easier to live there. The next thing we know about Kepler-22b is that it's about 15% closer to its star than we are to the Sun. If Kepler-22b existed in our solar system, it would be located somewhere between Earth and Venus. Does that mean we're all going to burn? No, silly. As I mentioned before, the star Kepler-22 is pretty cold, just some 10,000 degrees Fahrenheit. And that's why we can assume that the temperatures on Kepler-22b will be about the same as we have on Earth. If the planet orbits its star the same way Earth orbits the Sun, which we don't actually know, Kepler-22b can rotate around its star on its side, like, for example, Uranus. What? Didn't you know Uranus is actually lying on its side? Also, look at its rings. Yes, Uranus also has rings, like Saturn, but they're vertical. The universe is truly a mysterious place. So, if Kepler-22b is really something like that, then the weather on the planet will be, to put it mildly, not very good. Incredibly cold winters will be regularly followed by hot summers. And, just like with tidally locked planets, we'd be able to live more or less comfortably only on the narrow piece of land between these two crazy sides. Let's hope that this is not the case and the planet rotates normally. But it's not all that bad. Studies show that there may be an ocean on Kepler-22b. You already know that water means life, but in this case, it's also a big plus because a planet covered by an ocean always has more stable temperatures. The water absorbs some of the heat and distributes it evenly across the planet. The hot parts cool down, and the icy ones warm up. By the way, that's exactly what happened to Earth billions of years ago. When our planet started getting its first little puddles, our beloved moon helped these puddles to spread all over the planet. Thanks to this, a burning horror that used to be our Earth turned into a cute little ball full of life. So, if Kepler-22b has water but no atmosphere, scientists think that the average temperature there could be around 12 degrees Fahrenheit. But if there's also an Earth-like atmosphere, then the temperature can reach 72 degrees Fahrenheit. That would be nice. And finally, 1 year there is equal to 290 Earth days, about 9 months. The planet has no natural satellites, so unfortunately, we'd have to say goodbye to a beautiful view of the moon. On the bright side, we'd probably be able to see the sun as a distant little star. We could admire it in the night sky, remembering our home, while not hiding from giant spiders. And this is all that we know at the moment. Unfortunately, it's quite difficult to explore such planets, so there's a lot of very important data that we don't know. For example, what kind of planet is this anyway? Yep, we're missing the most important information about Kepler-22b. We don't know if it's a rocky planet or not. And if not, then all the previously mentioned information means nothing. It may turn out to be a gas planet, or a planet covered with gas but with a solid core, like Neptune, or a water world covered with a giant ocean. In this case, it better be a water planet. Then at least we could build some kind of underwater city there. We could filter the water and eat fish, until we evolve into an amphibious species. Does it even count as evolution if we go back to our roots? Scientists, however, think that Kepler-22b may turn out to be a Neptune-like planet. Some astronomers have even assigned the planet to a category of mini-Neptunes. Yes, this is a real planetary category. But this hasn't been proven yet. But even if, fortunately for us, Kepler-22b turns out to be a rocky planet, we still don't know what the atmosphere is like there. Does it exist at all? What if it turns out to be something like the atmosphere of Venus, which is more toxic than your ex? Then we'd have to dig deep underground to somehow survive on this planet. And then we'd have to come up with a heat source, because it's pretty cold underground. Yeah, let's hope this won't be the case. There are many possibilities with Kepler-22b. So far, we don't have a clear answer. But let's hope that scientists will find it before we load the first people into shuttles and send them to conquer Kepler-22b. That would be awkward if it turns out to be a gas planet, or something like that.
When watching a beautiful sunset over the sea and in the mountains, have you ever thought about what a sunset on Mars looks like? Or on Venus? Do they have the same reddish hues as sunsets on Earth? Not really. You see, Sunsets look very different on different planets because of the composition of their atmospheres. Sunlight scatters off of the molecules that make up an atmosphere. This process is more effective at shorter wavelengths, which is the blue end of the visible spectrum. That's why we perceive the sky on our home planet as blue. But at sunset, light needs to travel longer distances through the atmosphere. That's why we see yellow and red hues. Now, let's move to Mercury and check what sunsets look like there. Both sunrises and sunsets on Mercury are views to behold. The sun seems 2.5 times larger in the sky over this planet than when you look at it from the surface of Earth. It also rises and sets twice during a Mercurian day. It rises, arcs across the sky, stops, moves back to the rising horizon, stops again, and restarts its way toward the setting horizon. Such bizarre maneuvers occur because Mercury rotates 3 times for every 2 orbits around the Sun, and its orbit is extremely elliptical. But if you expect to see a blazing sky and the hues of red, you'll be disappointed. Mercury has almost no atmosphere, so its sky is always black since light doesn't get scattered at all. Let's continue our journey and go to Venus. There, at sunset, a bright yellow fades into orange, brown, and then when the sun disappears, black. The planet rotates on its axis very slowly, so to see a sunset, you'd have to wait almost 1/16 times as long as you would on our home planet, half of a Venusian year. Mars is widely known as the red planet because of its rusty color caused by the presence of iron oxide in its soil. But sunsets on this planet would look surprisingly blue if you watched them from the surface of Mars. Fine dust in the atmosphere of the planet scatters light and makes the blue hues around the sun's area of the sky brighter. A Uranian sunset is azure, fading into royal blue with some hints of turquoise. The pretty colors come from the interaction of sunlight with the planet's atmosphere, which mainly consists of hydrogen, helium, and methane. These gases absorb the longer wavelength red portion of the light, and the shorter wavelength blue and green light gets scattered when photons bounce off the gas molecules and other particles in the atmosphere. In 2014, scientists working with data received by NASA's Cassini mission showed what a sunset on Titan could look like. The largest moon of Saturn is surrounded by haze and smog. It's the only satellite in the solar system with a measurable atmosphere, which mostly consists of nitrogen, around 95%, and methane, about 5%. High in the atmosphere of this moon, the nitrogen and methane get split apart by the ultraviolet light from the sun and high-energy particles accelerated by Saturn's magnetic field. The compounds produced during this process create a thick, orange-colored smog. As the sun sinks toward the horizon, these orange hues turn into a deep brown. Now look at this. It looks like a sunset on Earth, right? But it might actually be what it looks like on Saturn. We have to say might because, just like all images from space, we can rarely get the color right. They are neither true nor false. They just represent the physical processes underlying the subjects of the images. As for the photo of a sunset on Saturn, it's hard to say if it looks exactly like this before we get more scientific data.
Now, Mercury is the planet that's usually closest to Earth. Does that surprise you? Did me. Venus certainly gets closer to us than Mercury. It can be as close as 25 million miles. After all, Venus is the second planet from the Sun, and Earth is the third. Even Mars gets closer to Earth than Mercury. The red planet can come as close to our home as 35 million miles, as it will in the year 2287. I won't be around for that. The average distance from Earth to Mercury is 48 million miles, but Mercury is still usually the closest planet to Earth. That's because Venus is usually somewhere on the other side of the Sun for 112 days, and Mars is usually far away in its highly elliptical, almost 2-year-long orbit. That leaves Mercury zipping between the Earth and the Sun every 44 days, and thus usually closer to Earth than either Venus or Mars. Hey, good trivia question to pull on your friends, isn't it? 22 spacecraft have successfully flown to Venus, and over 30 spacecraft have flown to Mars, but only 2 have ever gone to Mercury. So, what's so hard about going there? Well, it has to do with the Sun. Mercury is not only the planet that is usually closest to Earth, it is also the planet that is always closest to the Sun, 28.6 million miles close, to be precise. Being that close to the Sun creates navigational challenges, to put it mildly. Any spacecraft going to Mercury gets accelerated by the tremendous gravitational pull of the Sun. The spacecraft will be moving too fast to go into orbit around Mercury. That's why the first spacecraft that went to Mercury, the USA's Mariner 10, merely flew by Mercury 3 times, but made no attempt to achieve orbit around Mercury. The only other ship to go to Mercury, the USA's Messenger spacecraft, took 6.5 years to get there. Now that's a trip. Messenger did achieve orbit for a period of 4 years before finally running out of fuel and crashing onto the surface of Mercury on April 20, 2015. Many other spacecraft have flown to Jupiter in about the same time or less than it took Messenger to go to Mercury. The hang-up is the deceleration of the spacecraft. Quite simply, it takes too much onboard fuel supply to fire the engines in the reverse direction and break the speed of the ship against the Sun's great gravity. Slowing down sufficiently to get into orbit around Mercury is a no-go using rocket power. Some other way had to be found to slow Messenger down, a way that didn't use much or any fuel. Messenger was a hefty 2,400 pounds or so, loaded with 9 pieces of state-of-the-art scientific equipment. Now, 55% of the total weight, or about 1,300 pounds, was fuel. But this fuel would not be used to slow the spacecraft down. The fuel would be used for 5 engine burns associated with gravity assists and also for orbital adjustments once Messenger got to Mercury. Now, gravity assists uses the gravity of a planet and the planet's orbital velocity to either speed up or slow down a spacecraft. If the ship approaches a planet at a forward-moving angle, that is, an angle in the direction the planet is revolving around the Sun, then both the planet's gravity and the orbital velocity of the planet give the spacecraft a slingshot boost, greatly increasing the speed of the craft and sending it off in a different direction. This boost in speed can be added to by the spacecraft firing its rocket engines at just the right time. Both of America's Voyager probes use Jupiter's massive gravity to slingshot them to the outer gas giant planets and eventually out of the solar system. Gravity assist can also be used to slow down a spacecraft, as in the case of Messenger. By entering a planet's orbital path ahead of the planet's gravity pulls back on the spacecraft and slows it down. An engine burn is necessary at this time to escape the orbital path of the planet. Messenger performed 1 gravity assist flyby of Earth, 2 gravity assist flybys of Venus, and 3 gravity flybys of Mercury. Only then had Messenger been slowed enough to enter into orbit around Mercury. The probe traveled an astounding 5 billion miles to get to Mercury from Earth. That's farther than Pluto is away from Earth at its most distant. The name Messenger is an acronym, almost as clever as its intricate flight path to Mercury. Because Mercury is the fastest moving planet, the ancient Greeks appointed Mercury as the messenger of Olympus. News traveled fast even back then. Messenger really stands for Mercury Surface, Space Environment, Geochemistry, and Ranging. What do you think? Did they have a contest to come up with that? Now, the good news is, there's another mission to Mercury underway right now. It is a combined ESA-JAXA space mission that is bringing 2 orbiting satellites to Mercury. The mission doesn't use an acronym for its spacecraft, it has a real name, Bepi Colombo. No, it's not a cartoon character. Dr. Giuseppe Colombo, after whom the spacecraft is named, was an Italian mathematician and professor of applied mechanics. He worked with NASA on the Mariner 10 mission to Mercury. Bepi is Giuseppe's childhood nickname, which everyone knew and loved him by. NASA had been content with 1 flyby of Mercury, the first ever, But Professor Bepi calculated that with a slight adjustment of the flight path to enable a gravity assist at Venus, Mariner 10 could fly by Mercury again and again on different orbits around the Sun. Thanks to Bepi, NASA got 3 flybys of Mercury for the price of 1. Bepi-Colombo, the spacecraft, is scheduled to perform 9 gravity assist flybys, 1 at Earth, 2 at Venus, and 6 at Mercury itself. Each planetary deceleration slows Bepi-Colombo relative to the speed Mercury is moving around the Sun. This will allow for orbital insertion. Otherwise, Bepi-Colombo would head off into the Sun. Now, once in orbit around Mercury, Bepi-Colombo's Mercury Transfer Module, or MTM for short, will release 2 satellites, one European, the MPO, Mercury Planetary Orbiter, and one Japanese, the MEO, Mercury Magnetospheric Orbiter. Both are expected to orbit Mercury for 1 year. Altogether, the MCS, Mercury Composite Spacecraft, consists of the MPO, the MEO, the MTM, and MOSIF, which protects the spacecraft from the Sun and houses the electronics for MEO. This alphabet soup of mission components highlights the other reason it is difficult to get to Mercury. After 6 gravity assist slowdowns, 6 engine burns, 18 orbits around the Sun, 6.5 years of travel time, and 9 billion miles of distance, you have to bring a tailored complex of equipment. It's like that mountain picnic you'd like to go on. You can't just drive there. You have to hike a long way up a tricky mountain trail and bring along insect repellent, sunscreen, and your hat. Oh, and lunch and beverages. It's not easy. Bepi-Colombo has packed it all, including lunch. Nah, not really. The design is incredibly complex. Nothing can face the Sun, not even the solar panels. The solar panels must be kept turned almost to a right angle to the Sun, or the heat and particle flux will corrode the solar cells, and without electricity, you have nothing. Therefore, at right angles to the Sun, the solar panels must be extra long, as if there were only a little bit of sunshine. Bepi's solar panels are 50 feet long. The sun shield must remain gyroscopically aligned towards the Sun so that all instruments are always in the shade but still have a line of sight to what each is meant to monitor. And there are a lot of instruments, 5 in the JAXA orbiter and 11 in the ESA orbiter. It's one amazing picnic. Anyway, the science objectives are meant to add to what we have learned from the previous 2 missions to Mercury. The data collected by Bepi-Colombo will enable scientists to study the planet's interior and composition, along with Mercury's geology and surface morphology, Mercury's magnetic fields formation and evolutionary history, the planet's solar-wind interactions, and overall environment. As a metal-rich planet, Mercury may hold a vast wealth of minerals that MESSENGER failed to detect. Bepi-Colombo launched in October 2018 and still has a long way to go before it goes into orbit around Mercury. However, Bepi has already flown past Mercury and returned new photographs. The European Space Agency is excited about its first hot mission. All of the ESA's previous missions have been cold missions to objects further out into space, such as Mars, the asteroid belt, Comet Rendezvous, and elsewhere far out in the solar system. Well, all I can say is, best wishes to Bepi-Colombo. Let's hope all goes well on its 800 degrees Fahrenheit mission to Mercury. Let's hope that Mercury's long tail of exosphere gases, sodium, magnesium, and potassium, blown off the planet's surface by the solar wind, don't fog up the lenses or coat the solar panels. Have a nice time! Ciao, baby!
You take a giant straw and begin to inflate Saturn. It's getting bigger and bigger and bigger. That's enough. Now let's add some giant rings. That's it. This is Super Saturn, also called Saturn on steroids. It's a real object that scientists discovered in 2012, a planet named J1407b. And astronomers are still not sure what it really is. It could be a gas giant, like Jupiter or Saturn in our solar system. Then there would be no solid surface there. And if you wanted to set foot on that planet, you just fall through it, all the way to the core. But it could also be a brown dwarf, That's something between a large planet and a full-fledged star. Such objects have to be heavy enough to start thermonuclear reactions, like those going on inside stars. But the power of these reactions is too weak for brown dwarfs to glow and emit heat. To imagine the size and weight of J1407b, let's look at our Earth. If you put our planet on a scale, it'll show 6 and another 21 zeros tons. Our planet is also about 7,900 miles across. Now, that's Jupiter, the largest planet in our solar system. Its diameter is 11 times as great as that of Earth. It's also 318 times heavier. If Jupiter were a bucket, you could put 1,321 Earths in it. And this is the hero of the day, Super Saturn. It's almost 20 times as large as Jupiter. To balance the scales, you need to put 6,360 Earths on the other side. The planet's rings are so wide that if they were in the solar system, they would take up more than half the space between the Sun and Earth. And if Super Saturn switched places with the original Saturn, you'd see those rings with the unaided eye. They would be larger than a full moon. Presumably, these rings appeared in the same way as the ones around our Saturn. One theory says they're the remains of a moon that was once there. Its orbit was unstable, and over time, the moon got torn apart by the tidal forces of the huge planet it orbited. Small pieces of the former moon took their places in the giant's orbit. They collided with one another, like in a blender. After some time, everything that was left was basically particles of dust and ice moving around the colossal planet. Another theory suggests that the rings appeared after the moon collided with an asteroid or another moon. Then the gravitational blender did its job and turned the moon's debris into the rings. Some scientists think the rings formed at around the same time as the planet itself. So they're just the remains of the planetary nebula, which is a cloud of gas, space debris, and dust. Later, it probably shrunk and solidified to form a planet. We can only guess where Super Saturn got its rings from, but scientists say their mass is 80% of that of Earth. It may mean that the moon that used to orbit J1407b was about the same size as our planet. There's a little gap in the middle of these rings. Scientists think Super Saturn's moon might be there. If this is the case, it should be about the size of Mars. If scientists are right and Super Saturn is actually a brown dwarf, then this is an incredible discovery. Scientists will be able to watch it age. Supposedly, brown dwarfs lose their energy and shrink, fading in the process. And when a brown dwarf exhausts all its energy, it turns into a black dwarf. It's easy to confuse it with a black hole. People haven't discovered black dwarfs anywhere in the universe yet, because they take trillions and quadrillions of years to form. Our universe is too young, and none of the stars, even those that appeared when the universe was born, have had time to become black dwarfs. One of the oldest objects in the universe is the white dwarf, with a pretty long name, WD 0346 plus 246. It's about 11 to 12 billion years old and half as cold as our sun, and it's still cooling. It would need around 10 plus another 15 zeros years to turn into a black dwarf. For comparison, the universe is 1.4 and 10 zeros years old. Scientists believe that a black dwarf will exist for about 10 plus 25 zeros years, feeding on dark matter. After that, its protons, the smallest particles of matter, will begin to decay. And then, the black dwarf will simply evaporate. That will take another 10 plus 49 zeros years. But if the protons remain intact, a much more interesting scenario will await the black dwarf. In another 10 and 1500 zeros years, the black dwarf will become an iron star. It's essentially just a cannonball in space. The iron sphere will exist billions of times longer than our entire universe has existed, until it suddenly turns into a black hole. So, the process of the formation of a black dwarf is extremely long. It'd take a regular star an insane amount of time to age that much. But Super Saturn, if it is a brown dwarf, may be much closer to this state. Saturn on steroids is not the only strange planet in our universe. This is Gliese 436b. It's been detected using the transit method. A transit happens when a planet moves between its host star and an observer. It looks similar to a lunar eclipse. This planet is 4 times the size of Earth and 22 times as heavy. That's almost like Neptune. It's an exotic water world. The water there is solid, but it's not ice. It has a temperature of about 520 degrees Fahrenheit. The water in your pot turns into steam at 212 degrees Fahrenheit. But on Gliese 436b, the liquid remains solid because of the extreme pressure on the planet. Scientists have also discovered that the planet's atmosphere is evaporating into outer space. That's why there's a giant circular cloud around it. It's constantly moving in its orbit, giving the planet a long tail that looks like that of a comet. Cancri E holds incredible riches worth more than all the money on Earth. There are diamonds scattered all over the planet. Cancri E is about twice as wide and 8 times as heavy as Earth. This planet doesn't rotate. Only one of its sides always faces its host star. The surface temperature there is almost twice as high as the temperature of a burning fire. And since the host star is rich in carbon, the planet contains plenty of this element too. The intense pressure and temperatures help turn carbon into graphite and diamonds. Unfortunately, this planet is 40 light years away from our home, so it'd take about 730,000 years to get there on a regular rocket. Another planet rich in gems is HAT P7b. It's about 1,000 light years away from Earth. It's 60% as large and nearly twice as heavy as Jupiter. The planet is so close to its host star that it makes one revolution around it in just 2 Earth days. Because of such close proximity to the star, HAT P7b is almost as hot as a white dwarf. If you look at the night side of this planet, you'll see unusual clouds. Scientists believe that these clouds may be rich in corundum material. This is the very substance that forms rubies and sapphires, so it's likely to rain very expensive and beautiful gems there. WASP 12b is one of the darkest planets ever discovered. Only one of its sides faces its host star. The planet's surface is so dark that it eats up about 94% of all visible light, so it looks a lot like a black hole. The host star heats up the planet so much that the material there continuously evaporates. Then the star's strong gravity pulls this cloud toward itself, forming a disk. But TRES-2b is the champion. It's the darkest planet known to people. It absorbs 99% of the light coming from its star, which means it consumes more light than a piece of coal. 1% of the remaining light looks red as it gets reflected by this gas giant. From afar, this planet looks very evil. One of the oldest planets in the universe is PSR B1620-26b. It's about 12.7 billion years old. This means that it formed about 1 billion years after the Big Bang. The planet is so old that its 2 host stars have had time to evolve. One is a white dwarf. The other is a pulsar that makes almost 100 revolutions per second. Sunrises on this planet must be stunning. Right now, this star system is moving toward a dense cluster of stars. This is likely to lead to a stellar collision, so the fate of this planet is unknown. Kepler 438b is one of the most Earth-like planets. It's only 12% larger and is in the habitable zone of its host star, not too close and not too far away. It's a sweet spot where water doesn't evaporate because of the heat and doesn't turn into ice because of the cold. This planet might host life on its surface. In the future, it may also become a new home for humanity, but it would take people about 470 years to get to this planet, even if we traveled at the speed of light, which is impossible due to the laws of physics.
While we may think of ourselves as advanced after catching a glimpse of the 8 planets of our solar system and their 200 moons, we really have little idea of what's out there. So much so that there's speculation that there might be one more planet in our solar system. Scientists call it Planet X or Planet 9. This undiscovered world could be hidden way out past Neptune. Asteroids and dwarf planets in this area have weirdly unexplained altered orbits, and Planet X may be the reason. Tales of this mysterious planet began over 100 years ago with a man called Percival Lowell. Lowell had a great love of space, and aside from having an impressive mustache, he was also super rich. Ooh, that lucky guy. He used his riches to build an observatory in Arizona. He then dedicated it to study the odd motions of Uranus and Neptune. Their gravitational pulls are slower than those of all the other planets in our solar system. almost as if there is a giant hidden object pulling them off course. In 1906, Lowell theorized that there could be another planet out beyond Neptune. It probably caused those strange cosmic happenings. The man called this potential space body Planet X. In 1930, Pluto was discovered by Clyde Tombaugh at Lowell's very own observatory. It finally looked like people had an explanation for the weird orbital patterns. Lowell's team was on cloud 9 after the discovery, but their celebrations were short-lived. Soon, they found out that Pluto is way too small to be having that much of an effect on the surrounding planets. And it was also too far away from them, so it was back to the drawing board. Planet X, if it exists, is 10 times the size of Earth and 4 times its radius. It would take at least 10,000 years for the planet to orbit the Sun, and it would sit over 200 times further out than our home planet. That's 600 astronomical units from the center of the solar system. FYI, an astronomical unit equals the distance between the Earth and the Sun. But while that sounds super far away, it's actually not. The distance between space bodies is usually measured in light years, and an astronomical unit is a much smaller unit of measurement. For context, the most distant thing detected from Earth is the galaxy GNZ11. Cute name, huh? It sits a staggering 32 billion light-years away. Even so, our telescopes can still spot it, and just 1 light-year is the same as 63,241 astronomical units. Woo! So, if our tech can detect a galaxy that's so far away, how have we not been able to uncover Planet X? Well, it's probably down to the fact that it might not even exist. The theory of Planet X was pretty much debunked back in 1989. It was discovered that the mysterious gravitational pulls of Neptune had been a red herring all along. Scientists had massively misjudged just how big Neptune actually was. Voyager 2 visited the planet and discovered its actual size. This new info explained the odd gravitational pulls, meaning they weren't being caused by the so-called Planet X. But that's not where our investigation ends, as the hypothetical 9th planet once again popped up around 10 years ago. While the evidence behind Lowell's theory was wrong, his belief in Planet X may not have been. In 2015, astronomers Michael Brown and Konstantin Batygin discovered that there were, in fact, unexplained gravitational forces at play past Neptune. There are satellites that orbit planets perpendicularly, which doesn't happen anywhere else in our solar system. There's also clusters of asteroids that move in very specific ways, so specific that it's basically impossible that it could be random. Even weirder, there are satellites that travel in completely opposite direction to the Sun, unlike most other things in the solar system. A planetoid called Sedna also appears to be being pulled towards something, along with 6 others, all going in the same direction. And Brown and Batygin aren't just any other stargazers. They're both well-respected scientists at the top of their game. Konstantin Batygin has been named in Forbes as one of 30 scientists who are changing the world. And Mike Brown was the man who rebranded Pluto as a dwarf planet. This means that when these guys say something, it's usually pretty legit, and you should probably listen. But the only way we can really prove Planet X exists is to actually find it, and this has turned out to be pretty difficult. To locate the planet, we'd need to use a method called transit photometry. This is basically where we monitor a whole bunch of stars for a long time and look out for any dips in the light they give off. These dips would likely be caused by a planet getting in the way, and ta-da! The existence of Planet X could be proved. But for this method to work, Earth, the new planet, and the Sun all have to be perfectly aligned. These circumstances are pretty rare, and if these conditions don't exist, the dip in light won't happen. Plus, this method would only really work with planets that are closer to the Sun than our Earth. That's Venus and Mercury. For anything past Earth, this technique is pretty much useless. Another technique we could use is to find the potential planet through a good old-fashioned telescope. But as you can imagine, that's insanely tricky. The furthest object that we've found in our solar system is a planetoid appropriately named Far, Far Out. But that's only 140 AU away from the Sun. That's only like a quarter of the way to Planet X. We can only see an object because of its brightness. The Sun is very visible to us because it emits huge amounts of light. And we can see the Moon because it reflects the Sun's light. Technically, the Moon has no right to appear brighter than everything else in the night sky. It only seems brighter because we're closer to it. The farther away an object is, the less bright it appears to us. The major issue with seeing the theoretical Planet X is that all objects in our solar system get their light from the Sun. They reflect sunlight, and that's why we can see them. Given how far away from the Sun Planet X might be, it makes it nearly impossible to see. And because of its really dim light, to view it, we would require perfect weather conditions as well as an extremely strong telescope. But Brown and Badigeon have found the perfect one. The Subaru telescope is located at the top of a dormant volcano in Hawaii. It's huge and is capable of capturing even the weakest light from distant space objects. The issue that we need to figure out is where to point it. Without knowing where Planet X actually is, this basically turns things into a giant guessing game. There are also only around 3 nights every year when the conditions are clear enough to see the hypothetical Planet X. It's difficult, but not impossible. And still, most astronomers have called it a day and agreed that Planet X doesn't exist, stating that it's just a common myth. The most widespread explanation for the weird gravitational pulls is that there's a tiny black hole in our solar system. It's pulling the planets toward us. But don't worry, they say it's not big enough to actually munch on a planet. So Earth is all good, for now. The issue with the black hole theory is that, once again, it's almost impossible for us to track the thing down. While its mass could be as great as that of Planet X, the hole itself would be squished down to the size of an orange. Telescopes wouldn't be of any use. To find it, people would have to look for the gamma rays sent off by objects as they fall into the black hole. Another way we could find it is to release hundreds of tiny spacecraft. They would pass close enough to the hypothetical hole, and when they got pulled toward it, we could probably detect it. But don't count out Brown and Badigeon's theory. It's still being documented by NASA. And until we find unmistakable evidence to prove any theories, Planet X might still be out there.
It's there. I finally see it, for the first time in my life. Grayish body far away in the sky, hidden behind the clouds, the size of 1/4 of a full moon. It won't be there for long. The last time it was there was 33 years ago. And we'll have to wait for 33 years more to see it again. Tellus, the mysterious planet humankind still have so much to learn about. For a long time, Earth was the only planet quietly traveling its circular orbit around the center of our solar system, the Sun. Our solar system was generally a pretty stable place. Jupiter, Saturn, Mars, and other planets, they all acted in a predictable way. Always the same orbits. Until some time ago, something unexpected happened. Another planet entered the Earth's orbit. No one knows where exactly it came from, since it wasn't one of the 7 planets from our solar system. We had advanced devices that tracked asteroids, meteorites, and other space bodies, but scientists were still terrified when they saw such a big, round body suddenly coming toward us at a great speed. First, they thought it was a huge asteroid and were afraid it would collide with us. Humankind was prepared for the worst because it was too late to deflect it. But when the huge body came closer, to the distance of 93 million miles, which is the average distance between the Earth and the Sun, it suddenly changed direction. We now know that's the closest it could get to the Earth, with the size similar to our planet. The orbiting body needs to meet 3 criteria to be called a planet. It needs to be a perfect sphere, orbit the Sun, and can't orbit any other body, like another planet. It also needs to have a clear orbit of any protoplanets, planetesimals, or other planetary competitors. Scientists were tracking the orbit of the new planet they later named Tellus, which is a Latin word for Earth. When it entered the Earth's orbit, it was like something happened with their gravitational forces, so these two planets created a completely new orbit, in the shape of a horseshoe. Planets could be in the same zone around the Sun in such an orbit. That means they don't move in a circle around a star, but each goes along the edge of some sort of track in the shape of a horseshoe with crescents that face each other, like two halves of a broken ring. For example, Saturn and its two moons, Janus and Epimetheus, they dance around Saturn with the stable horseshoe orbit and travel around 93,000 miles from Saturn, beyond its main rings. The closest they come to each other is 9,300 miles. Nothing occupied our media for years but new mysterious events. It was chaos at first because we didn't know how things would end. No one went to school, work, college. We were all waiting for directions on what to do. People were first very afraid, but later excited when we found out that's a planet similar to Earth, which means we could get new friends. Scientists believe Tellus used to share the orbit with some other unknown planet in another solar system. We never had two planets sharing the same orbit, but some other solar systems could have it. When two planets share the orbit and get closer, one can kick another from the orbit in the unknown direction or even be pushed into the Sun because the gravitational forces of two planets interact. If two gravitations would attract each other, they could start moving towards each other and bam, big collision. Or they could successfully share their orbit, shaping a horseshoe orbit-like path, something that happened with Earth and Tellus. It's not the first time it happened to Earth. 4.5 billion years ago, when the solar system existed for only a few tens of millions of years, there was a space object as big as Mars moving towards our planet and slammed into it. The theory says the Earth pulled the debris from that planet into its orbit, and those pieces eventually formed the moon we have today. The collision probably caused resurfacing on the Earth. The oldest rocks we found on our planet are still younger than some meteorites we found. Uranus probably also had a huge collision. Billions of years ago, there was a space object at least twice bigger than the Earth, and it came very close to Uranus, the gas giant. Two bodies collided with the force so powerful it made Uranus shift into its side, but it's survived. But it's been rotating on its side, different than any other planet in our solar system ever since then. The early solar system was created because gravity pulled a cloud of gas and dust together. It was a chaotic place where debris was constantly slamming into other planets that were growing and forming at that time. Two planets can hardly share the same exact orbit because they can't remain stable. Quasi-stable orbit maybe, which technically means no order. Everything is unstable. Why we can't be completely relaxed with Tellus, even though things look good now. It doesn't mean the collision will happen right away. It can take billions of years before that. There are things called Lagrange points, 5 specific points where the gravitation of some planet and the Sun cancel out. If you consider masses as just one planet and the Sun, all three bodies can move in a predictable orbit forever. But out of these 5 points, only 2 are stable. Anything that happens in the other 3 will cause trouble. Also, 2 of them, L4 and L5, are points where asteroids collect. Gas giants have thousands of these, but our planet has only one, the asteroid 3753 Cruenia, and it's in the quasi-stable orbit with our world. It's not going to remain stable forever, but if it was like this, 2 planets can share orbits. Days are a little bit longer now, the year is also longer. We still can't settle for the calendar because the conditions are still changing and the planets are still adjusting to their new orbit. The climate is the same for now, probably similar to one on Tellus, since we're in the same disk around the Sun. We discovered it's pretty similar to Earth and has similar conditions, which means we could maybe live there in the future. The planet comes to the closest point every 33 years, and later it's behind the Sun, so we're slowly collecting data about conditions. We were thinking about moving there, but then something exciting happened. We started getting messages from space for the first time. They came by radio frequencies in some unknown language. We're currently trying to decipher their messages and, at the same time, preparing for their first visit. We believe whoever's out there comes in peace. They've come a long way to our solar system. Today is the day we are going to visit Tellus for the first time. In fact, the spaceships are going to be there any minute. They went there 9 days ago. Journalists are ready. People are cheering. Cameras are on. We're all waiting. Today, Tellus is at the closest point and won't stay there for too long, maybe a couple of days. So we don't have that much time to explore it and see who's there. I hope we'll be able to visit them. make new friends, collaborate, travel to see new places. Till now, we only saw some pictures scientists took from the distance. It seems they have lots of water. Researchers believe many waterfalls, lakes, but much deeper and wider than ours. Perhaps hiding some magnificent creature we don't have. They think there could be volcanoes. Maybe we'll find something bigger than Olympus Mons on Mars, which is the biggest volcano we found in our solar system, which is the size of Arizona, a staggering 370 miles across. Maybe it has super strong winds, like Venus, whose winds are 50 times faster than its rotation. Who knows if there's water ice, the matter that exists all over our solar system, some in shadowed craters on the Moon and Mercury. Maybe Tellus will change its size, like Mercury, that has cliff-like landforms with relatively small fault scarps, so we believe it's slowly but constantly shrinking. Tellus perhaps has tall mountains, like Pluto, which isn't the planet but still has impressive icy mountains, 11,000 feet tall. Anyway, today's the day when we find out. Wish us luck.
You take off from Earth and park your spacecraft somewhere near the Moon. You're now almost 240,000 miles away from your home planet. That's almost 100 widths of the United States. Now you take out a giant hammer and an enormous chisel using the robotic arms of your spaceship. You place the chisel at the Earth's North Pole and strike its head with the hammer. Earth splits open like an eggshell, and you see it, another planet. It's Theia, and it's hiding inside our planet like a yolk in an egg. You'd need to go back in time 4.5 billion years to find out how it got there. This beautiful nebula will soon become our solar system. Colored dust and various space debris are slowly coming closer toward the common center. Soon this jigsaw puzzle of debris becomes too heavy and dense. The temperature inside the giant is rising. Soon it gets so high that it triggers a nuclear chain reaction. Another second and bam! There's an explosion so powerful that the shockwaves travel far into dark space, and the blinding flash from this blast can be seen from the other side of the Milky Way galaxy. When the dust clears a little, you can see that a bright light is still shining at the very center of the explosion. This newborn star is the Sun. It weighs as much as 333,000 Earths. If the Sun was a bucket, you'd need 1.3 million Earth-sized planets to fill it. You're interested in a small object over there, 93 million miles away from the Sun. This pile of rocks and hot lava is Earth. Right now, the planet is busy forming its core, while the oceans of lava are gradually cooling down. But a few tens of million years after the Sun's birth, you notice a strange object hurtling toward Earth. It's Theia. This small planet was born at about the same time as Earth, and now it's following a crazy spiral trajectory at enormous speed. Scientists believe Theia was kind of a ball Jupiter and Venus played with. Venus was pulling Theia in one direction, then Big Brother Jupiter pulled it back. But the Sun makes up 99.8% of the mass of the entire solar system. That's why the star sets its own rules. It makes Theia move in almost the same orbit as Earth. So they inevitably come closer and closer to each other until they become next-door neighbors. We see that Theia is the size of Mars and as wide as the Atlantic Ocean from New York to Portugal. A collision can't be avoided. Theia is traveling toward Earth at nearly 9,000 miles per hour. That's 11 times faster than the speed of sound. If the smaller planet crashes into Earth at a particular angle, Earth will most likely be torn apart, as well as Theia itself. The collision will cause a huge blast, visible on other planets even on a bright day. Nothing will be left but some burning dust and debris. Even if Theia touches Earth only lightly, it'll still knock out a chunk of our planet the size of Australia. But the collision with Theia happens at a perfect 45-degree angle. It strikes the Earth at tremendous speed. The explosion literally vaporizes huge amounts of rock, and the shockwave sends the remaining debris into Earth's orbit. A huge crater is formed at the impact site. Soon it gets filled with boiling lava. The remnants of Theia and the ejected fragments of Earth begin to orbit our planet. According to one version, these fragments form two moons. At first, they travel together, but one day they get too close to each other and collide, forming one large space body. The other theory claims that all the shards start being pulled by the remnants of Theia. Sometime later, they form the moon as we now know it. At that point in the past, though, it's just red-hot rock and lava. The collision at this angle slightly tilts our planet and accelerates its rotation. It's because of Theia that we have different seasons and 24 hours in a day. Earth has lithospheric plates. These are enormous solid pieces that make up the crust of our planet. After the collision with Theia, they start to break and crack. It causes carbon, a primary component of all known life on Earth, to start moving all over our planet. So, Earth gets some kind of metabolism. After a few 100 million years, the first living creatures start to appear on our planet. Over nearly 4 billion years, simple single-celled organisms have been evolving into the life you see today. According to scientists, such a collision is a very rare event. The probability that somewhere out there, there's a planet like ours that has survived the same catastrophe is extremely small. This may be the reason why we are yet to find traces of other civilizations out there in space. Meanwhile, the remains of Theia are still here on Earth. Of course, it doesn't look like an entire planet stuck inside our own. Most of the fragments have melted and blended into the Earth's crust. If you take the top layer off our planet, you'll see 2 huge lava blobs the size of entire continents. They're right below Africa and the Pacific Ocean. Presumably, these are the remains of Theia. They didn't mix with Earth's mantle because of different densities. It's like mixing water and oil in a glass. The oil will always float up over the water and create an even layer on top of it. But if you raise those lava patches up to the surface, they'd be 100 times higher than Mount Everest. Other remains of Theia might be on the moon. The Apollo space missions brought back many soil samples for analysis. Scientists have concluded that the moon is very similar to Earth in structure. People could drill deep down and take samples there. Then they'd analyze the blobs from Earth. If their structure matched, it'd be 100% proof that Theia did hit Earth 4.5 billion years ago. And that's how we got the moon. But for the time being, Theia remains somewhat mysterious. Scientists are still not sure that the planet actually existed. The whole idea perfectly fits the model of the moon's creation. But in fact, this incredible collision may have never happened.
Hop on the bright side of life together with our brand new tees, hoodies, and more. Click the link to pick your choice.
Now you travel 41 light years away from Earth to the planet 55 Cancri E. It's about twice the size of Earth and 8 times heavier. You take out your giant hammer again and use it to hit the chisel. The planet cracks, and you see it's a giant diamond. The temperature on this planet is tens of times higher than that of Earth, and its soil is rich in carbon. The heat puts a lot of pressure on this carbon. Its structure changes. First, it turns into graphite. Some more pressure, and graphite turns into diamond. On Earth, diamonds form at depths below 60 miles, where the pressure is 50,000 times greater than on the surface. The temperatures there rise over 1,000 degrees, which is as hot as fire. Diamonds are ejected closer to the surface in volcanic eruptions. Still, people have to dig mines 1,500 feet deep to find these beautiful gems. The Golden Jubilee diamond is the biggest cut and faceted diamond on Earth. It weighs as much as a chocolate bar and is the size of a hamster. Its price is about $12 million. Now imagine a diamond the size of an entire planet. You decide to fly back to the solar system. Your destination is Jupiter's moon, Europa. It's as wide as the distance between Seattle and Houston, and its mass is less than 1% the mass of Earth. Its surface is enclosed in an icy crust. It's about 19 miles thick. But what if you crack this crust with your giant hammer? Wow, Europa is completely covered in water. It's freezing here, 3 times colder than at the North Pole on Earth. The water turns into ice almost instantly, but the ocean beneath the surface is still liquid. Europa interacts with Jupiter gravitationally, just like the moon with Earth. This creates tidal forces and heats Europa's core. The core melts the ice around it. The result is a huge ocean, 2 to 3 times larger than all of Earth's oceans combined. Scientists believe that water is the basis of life. It may mean that life may exist on Europa. There could be thermal springs, just like at the bottom of our oceans. The water there is probably much warmer. And even though the pressure and temperature in such places are likely to be extreme, simple bacteria may live there. Europa is almost the same age as Earth. This means there's been enough time for living organisms to appear and evolve. Who knows? Maybe some advanced civilization is already blooming under this crust of ice. They may be building big cities and dreaming of conquering space right now. But the only thing people can do at the moment is send a probe to Europa and find out if life is possible there. When you explode planets, things get red hot. Atmospheres are stripped away. Stuff is flying apart. Everything collapses. The world becomes brighter than a dozen suns. You squeeze your eyes shut and cover your ears. Your hair stands on end. The sheer power of a cosmic blast is terrifying. Some time before the explosion, you're hovering in almost complete darkness. Below, you see the moon, or what you think looks like the moon. The surface of this light-colored sphere is pockmarked with craters left by meteorites. You see huge, steep hills stretching for miles. It's Mercury, and right now, you're going to explode it. As if in slow-mo, you watch the planet fall apart. And then, in the blink of an eye, you see a wall of debris closing in on you. First, giant chunks of rock. Those are all that's left of the planet's solid crust and rocky mantle. The appearance and structure of the debris flying in your direction changes. Now, the stuff looks liquid, like splashes of quicksilver. That's Mercury's metallic core bursting apart. It used to take up 85% of the planet's volume. And finally, it's a firework of solid pieces again. It's the planet's solid core. The explosion is so powerful, it knocks Earth into a different orbit. The sun hiccups and swallows down an enormous cloud of dust. That's everything Mercury has left behind. But don't worry, our solar system won't lose any planets. This whole explosion thing is only a temporary experiment. Once you're done watching the show, you press another button, and the planet gets back together, as if you've hit rewind. You approach the next planet on your way. Its surface is hiding under a super dense atmosphere made up of carbon dioxide. If you decided to land on Venus, you'd watch thick clouds of sulfuric acid pass by. You'd see the planet's surface, reddish-brown, dry, and incredibly hot. You'd probably walk across flat, smooth plains, covering 2/3 of the planet's surface. You'd gawk at volcanoes littering Venus, all 1,600 of them. Unfortunately, you won't be able to do that because you press the button. Boom! Huge chunks of basalt fly away from the center of the explosion. That used to be the planet's 12-mile thick crust. Then you spot bright burning meteors flying towards you at incredible speed. Those are chunks of Venus's molten rocky mantle. The fire rain seems endless, maybe because the mantle was 1,200 miles thick. But that's not the most massive part of the planet. The power of the explosion forces apart Venus's metallic iron core. This core used to be twice as wide as the mantle. You reach the blue marble of your home planet. What will its insides look like, scattered in space? From above, Earth looks pretty. 71% of its surface is blue, because of all that water, seas and oceans. There are also areas of green, yellow, and brown and white swirls. You press the button. The planet bursts apart in a hailstorm of rocks. They're what's left from Earth's thin crust and much, much thicker mantle. It used to take up nearly 84% of the entire planet's volume. You see the rocky rain change into something way more liquid. It's scorching hot iron and nickel that used to make up Earth's outer core. The metals weren't under enough pressure to be solid. The bang is so powerful that it takes apart Earth's inner core. It used to be a solid ball of iron and nickel. After the pieces fly apart, they follow their own orbits around the sun. The most massive chunks crash into the moon, and some travel further and get swallowed by our star. You can't linger. The red planet is waiting for you. The surface of Mars is covered with rusty-colored dust. The thickness of the dust layer varies from area to area. but in most places, it's 7 feet thick. The ground is colored gold, brown, tan, and even greenish. The hue depends on the minerals that make up the soil. The planet's surface is rocky. It's covered with dry lake beds, craters, volcanoes, and canyons. Bang! Mars is a rocky planet. You have to dodge mountain-sized chunks of crust made up of volcanic basalt rock. What you see next looks as if you've blown up huge amounts of soft, rocky toothpaste. That used to be Mars's mantle, composed of oxygen, silicates, and other minerals. And then, the flying pieces get solid again. Ah, it's the planet's core's turn. It was solid, made mostly of iron, nickel, and sulfur. Billions and trillions of fragments of all sizes, from a small moon to pieces several feet wide, get launched in all directions. But only very few parts have enough momentum to leave the solar system. The whole event slightly changes Earth's orbit, and the temperature on our planet goes up by 18 degrees Fahrenheit. You leave rocky planets behind and close in on the first gas giant on your way. It's Jupiter. Thick brown, yellow, red, and white clouds hide its surface. They make the planet look colorful and beautifully striped. You hit the button. This time the view is different. Instead of chunks of solid crust, you see jet streams of gas accelerating from the planet's center. It's what used to be Jupiter's atmosphere, made up of hydrogen and helium gas. In no time, the matter hurtling away to space turns liquid. That's hydrogen changing its form under immense atmospheric pressure closer to the center of the planet. A bit later, the liquid is already a mixture of metallic hydrogen and helium. And finally, something solid. It was probably Jupiter's core, 14 to 18 times the mass of Earth. The gas giant's diameter was about 90,000 miles, but the blast lasts no more than half a second. The explosion of Jupiter is so strong, it evaporates smaller planets like Mars and Earth. The sun remains pretty much untouched. It gets hotter and kinda unstable for a bit, but it doesn't last long. The next gas giant on your way is Saturn. At first sight, it looks as if the planet has a surface. The seemingly solid yellowish-brown sphere is surrounded by layers of clouds. Saturn's trademark rings are awesome and colorful, gray, beige, and tan. They're actually groups of tiny ringlets that are made up of floating chunks of water, ice, rocks, and dust. These chunks range in size from specks to massive skyscraper-sized pieces. While orbiting Saturn, they keep colliding, and larger pieces get shattered. You're surprised to see that the rings aren't perfectly round. They have bends caused by the gravitational pull from the nearby moons. 53 of them are confirmed. Titan, an icy world bigger than our moon and even Mercury, is the largest. What you see looks eerily similar to what happened when you exploded Jupiter. There's only one difference. Saturn's rings break apart, sending rocks and ice flying into space at incredible speed. The largest pieces crash with the planet's moons, wiping away the smallest of them. You see streams of gas, mostly hydrogen and helium, with a bit of methane, ammonia, and water. They're moving at breakneck speed away from where the center of the planet used to be. After that, splashes of liquid matter. That's liquid hydrogen that later turns metallic. And finally, the chunks of the solid core made up of rocky materials. You're looking at a beautiful blue-green sphere of the ice giant Uranus. The planet gets this unusual hue when the light from the sun gets reflected off the planet's surface. Plus, Uranus's atmosphere is mostly hydrogen and helium, with traces of methane gas that absorb the red light. Anyway, bang! This time, it's massive blobs of ice that are hurtling in your direction first. They used to be the part of the planet's ice mantle that once made up 80% of the planet's volume. But why does this ice look liquid? On Uranus, frozen liquid isn't solid like on Earth. Ice is a hot, dense fluid made up of water, ammonia ice, and methane. It's often called the water-ammonia ocean. After the bizarre ice rain, you see solid pieces of the planet's rocky core. It used to be small, no more than half the Earth's mass. Some of Uranus's moons get pulverized in the explosion, and several even get ejected out of the solar system. The explosion also slightly shifts Neptune's orbit. And the last planet on your way, Neptune. It looks blue because of a layer of swirling gas and permanent clouds. No time to linger. Boom! The planet doesn't have a solid surface. That's why, after pressing the button, you see Neptune's liquid mantle bursting. It looks like a water-filled balloon thrown down from the 50th floor. This sends splashes of water, ammonia, and methane ices away into space. It's followed by lava-like remains of the planet's mantle. It used to be liquid, red-hot, and rich in methane, ammonia, and water. That's what's left from Neptune's solid core, made up of iron and other metals.
We've been focusing on trying to find life on Mars so much, while there's this gem waiting to be explored. This planet is the 6th farthest from the Sun and the 2nd largest in the solar system. You'll find it right behind Jupiter. I'm talking about Saturn, or as they sometimes call it, the jewel of the solar system. It's so different from our planet. First of all, you wouldn't be able to stand there. While Earth consists of rock and other tough stuff, this planet is like a giant ball, mostly made of gases. If you found a swimming pool huge enough to fit Saturn, you could see the planet floating in the water. No wonder, Saturn is the least dense planet in the solar system. It also contains a lot of helium. You know, the gas you put in balloons to make them hover in the air. Saturn is a very windy planet. Winds there are more than 4 times stronger than the ones we have on Earth. A day over there lasts 10 hours and 14 minutes because Saturn spins on its axis pretty fast. But the planet takes its time while going around the Sun. A year there equals 29 Earth years. Saturn's radius is more than 36,000 miles. It means the gas giant is 9 times wider than our planet. If Earth was the size of a nickel, Saturn would be as big as a volleyball. Even though some of our planets in our solar system also have rings, Saturn's are the most spectacular ones. You can even see its rings from Earth. And no, you don't have to be a scientist with insanely expensive equipment. All you need is a small telescope. Saturn's rings are not firm. They are made of pieces of dust, rock, and ice. Some of them are as small as grains of sand, and some as big as a house or even a mountain. These are actually bits of asteroids, comets, and shattered moons that fell apart before reaching Saturn. They could be torn into pieces by the planet's powerful gravitational pull. Saturn has over 50 moons, and recently, scientists have discovered some unusual hydrothermal activity on one of them. Enceladus is Saturn's 6th biggest moon. It has 4 tiger stripes close to one of its poles. Researchers have found that there is an ocean underneath these stripes. Water and ice erupt from that area, so now we can't but wonder, maybe there's life out there. In the oceans on Earth, some forms of life gather around similar hydrothermal vents. They feed on the chemicals there, same as plants on the surface do with sunlight. And not only that, some of the oldest microbial life on our planet feed on the same energy as the one produced beneath the ocean's surface on Enceladus. It could potentially mean there's life developing there right now. Of course, it takes millions and millions of years for even the simplest organisms to appear. But hopefully, scientists will need less time to find more complex forms of life. There are millions of exoplanets out there in space, and scientists have been searching for those that could be potentially habitable. Exoplanets are planets orbiting a star outside of our solar system. Dwarf stars are similar, less luminous than the Sun. They sometimes live for more than 10 billion years. That's enough time for a living organism to develop and evolve into a more complex form. Life might appear on the planets orbiting such dwarf stars, or, like with Saturn, on one of their moons. And here it is, Gliese 876b, that orbits the red dwarf star Gliese 876. This planet is mostly a mystery, but scientists assume this is a gas giant that has no solid surface. They believe its atmosphere doesn't have clouds, but there might be water in its liquid form on the planet's surface. T-Gardens b orbits a red dwarf that's around 12 light-years away from our solar system. The planet's mass is just a bit higher than that of Earth. Scientists think it may have a rocky surface. The planet needs around 5 days to complete its orbit. It means that 1 year on T-Gardens b is actually shorter than 1 week on Earth. Somewhere far, far away, there's another potentially habitable planet named Kepler 1638b. Okay, to be more precise, it's 3,000 light-years away from Earth in the constellation Cygnus. This planet is 4 times as heavy as Earth and twice as wide. It needs almost 260 days to complete one orbit around its star. The gravity on this planet is stronger than that on Earth. It wouldn't be an easy feat to jump on its surface. One more Kepler coming along. This time, it's Kepler 62e, a planet that's more than 1.5 times the size of Earth. Scientists believe this one has a warm, humid, and hospitable atmosphere with cloudy skies. There are 1,200 light-years between Earth and this planet. Kepler 62e needs 122 days to orbit its red dwarf star. Its neighbor, Kepler 62f, is another potentially habitable zone. It's a world around 40% bigger than Earth. Scientists think this planet might be covered in water. The oceans on our planet are full of interesting creatures and organisms of all sizes, so the chances are this planet also hides some intriguing living beings, or at least it has the potential to develop life. When we say habitable, it doesn't mean life definitely exists there. It just means there are conditions for some forms of life to develop. LHS 1140b is a planet located in one of the potentially habitable zones. Unlike its gas companions, it's solid and quite rocky. The planet's radius is 60% larger than that of Earth, and its mass is 7 times bigger. It's one of the densest planets found out there. Since the planet has a big mass, an atmosphere there must be rather thick. Plus, gravity on its surface is much stronger than here on Earth. That's why you would likely have problems just standing on that planet. Hello and greetings from TRAPPIST-1, an ultra-cool dwarf in the constellation Aquarius. It's around 39 light-years away from us. 7 Earth-sized rocky planets are orbiting in the star's habitable zone. All of them can potentially have some water on their surfaces. The temperature on these planets is more or less similar to that on Earth. On the Moon, gravity is only 16% of what we have on our home planet. That's why the astronauts could hardly control their movements when they visited our natural satellite. But when it comes to the gravity on TRAPPIST-1 planets, you would probably feel good and comfortable there. And Kepler, once again. This time it's Kepler 452b. It's a rocky planet 60% larger than Earth. Its parent star is similar to our Sun. This planet has actually spent around 6 billion years in the habitable zone, while Earth has been there for a mere 4.5 billion years. This planet needs 385 days to orbit Kepler 452. This star is around 20% brighter than our Sun, but has the same temperature. The whole system is very far from our little oasis. It would take you 28 million years to get there. And now, how about KOI 7711.01? It's another intriguing world 1,700 light-years away from us. This planet is only 30% bigger than Earth. It gets almost the same amount of heat as we receive from our Sun. Sometime in the future, people might start colonizing the galaxy. They would be looking for new planets to live on. Then we'd certainly have to make really long trips, and maybe one day we'd reach Proxima Centauri. It's a nearby star that has a couple of planets we could potentially inhabit, like Proxima Centauri b. It's around 4 light-years away from Earth, and it doesn't sound that far at first, but it actually is. It would take about 6,300 years to travel there, if we use the technologies that are available these days. It would need many, many generations to make a trip like that, and it would take even longer to finally inhabit that new world. People would be born and raised on spaceships. They would live their lives there without ever seeing either Earth or the planet they're heading to. Instead of trees, mountains, and rivers, there would be only the dark nothingness of faraway galaxies spreading in front of them. They would never be able to wander unknown streets, breathe in the fresh air, feel the wind. The only place for them to travel to would be another part of the ship. Certainly, such a journey wouldn't be simple, but it would pay off if people managed to build some more beautiful worlds, like the one we have here on Earth. Is that even possible? Time will tell.
Magma oceans, supersonic winds, scorching hot days, and instead of rain, a bunch of rocks falling on your head. Just another one of those days, huh? Astronomers recently discovered a new super planet out there. K2 414b is an exoplanet that's around 200 light-years away and in serious need of a new name. An exoplanet is just a fancy way of saying that a planet orbits its own star in another solar system. The Earth orbits the Sun, so this planet has its own orbit party going on. So what makes K2, bunch of numbers, so scary? Picture our beautiful little blue planet Earth. Now imagine that all the volcanoes in the world suddenly erupted at the same time and lava covered the oceans and seas. Fiery hurricanes, thousands of times faster than normal, blow all over the place, 24/7. And it starts raining rocks every now and again. Rocks, like on your head. Thankfully, not in your head. This scary planet came into our lives about 2 years ago. Scientists are still studying it. So, what's a typical day like? For starters, you can forget about breathing. Oxygen decided to take a pass on this planet. You'd have to get used to sodium, silicon monoxide, and silicon dioxide, which is, as you guessed, not great. And that's just scratching the surface. Who knows what other chemicals are lying around? And yes, magma oceans. The planet's surface is covered in molten magma as far as the eye can see. This lava planet orbits really close to its star, which is why the surface is like a fireplace. The closest planets to our Sun are Mercury and Venus, but this planet's even closer. And what's even more weird is that half the planet is in constant daytime, the other half night. It's tidal locked, just like our moon is. No matter how long you stare at it, you'll never see the other side. That's why the all-day, everyday scorching fiery side is so hot and overflowing with magma oceans, while the other side's in a constant state of deep freeze. If the magma doesn't burn you, you've still got big problems, and please don't look up. It's raining rocks. On Earth, water turns to steam, rises up, becomes clouds, cools, and falls as rain. Over there, on planet Fireball, it's exactly the same, except for it's rocks, people. The planet's so hot, it vaporizes rocks. Oh, and don't forget the supersonic winds with speeds up to 3,000 miles per hour. Imagine your hat getting blown off your head at 5 times faster than an airplane. The strongest wind on Earth was the tropical cyclone Olivia that hit Australia. It was blowing at 250 miles per hour. Now imagine 12 times that. On the sunny side of the planet, you're looking at a roasting 5,000 degrees. The hottest it ever got on Earth's surface was in California, 135 degrees. It's pretty common for it to get near that temperature in the Sahara Desert, but that kind of heat's not exactly enough to make rocks evaporate. If you grew up near a desert, you already know how dry and hot it always is. But did you know that deserts can reach freezing temperatures? A desert, by definition, is a large area with little or no rainfall. That means no water vapor to keep the temperatures from going insane. In the daytime, the sun heats up the desert like an oven. But when the sun sets, the heat packs up and heads home, and it can get really cold. Some deserts have even reached minus 40 degrees at night. But wait, shouldn't deserts have snow if it's that cold? Well, some deserts have had a bit of snow here and there, but because there's no water vapor, there can't be that much snow. Just dry, freezing, sandy Sahara nights. Now, the Sahara Desert's actually not the largest desert on Earth. It's Antarctica. 5 million square miles of icy dryness, almost no people, and a whole bunch of cute penguins. Penguins technically live in a desert. Back to the Fireball planet, this time the night side. Never-ending darkness and extreme cold, about minus 330 degrees. Add in some supersonic winds? Earth's coldest? Minus 130 degrees at a research center in Antarctica. So, how does this jalapeno pepper exoplanet stack up against some of our neighbors? Well, Mars isn't exactly livable either. It's the red planet, so you'd think it'd be hot most of the time. But it's usually freezing, well, way below freezing. And if you're planning a weekend getaway to Mars, you can leave the umbrella at home. Nah, it doesn't rain rocks, and it actually hasn't rained there for millions of years. At least Mars has days and nights, and it's like Earth in other ways. Mars' equator is steamy hot, and it gets pretty cold at the North and South poles, just like Earth. Scientists even discovered old bits of carbon dioxide snow there. The entire planet is actually covered in carbon dioxide, with a splash of nitrogen here and there. Scientists even reported intense snowstorms on Mars. But because it's mostly carbon dioxide, it's not your typical snowstorm. It's more like a dry ice storm. That's the stuff they use in fog machines. Mars isn't the only place where climates are going cuckoo. Jupiter's famous for its gigantic storms. Not like the ones we know on Earth. I'm talking about storms that last for centuries. The Great Red Spot on Jupiter is actually a 400-year-old storm, and you could fit 4 whole Earths inside of it. So it's been around for a while, but it's nowhere near as intense as the storms on K2. Venus also has intense rain, but it's not made of rocks. It's sort of worse. It rains sulfuric acid. That stuff can give you severe skin burns and rip nasty holes through your umbrella. Venus's atmosphere is filled with carbon dioxide, which acts like a net to trap in the sun's radiation, and it's insanely hot. No magma oceans, though. Mercury is the closest planet to the sun and doesn't even have an atmosphere. That means no storms, clouds, rain, wind, whatever. Mercury is kind of like a desert here on Earth. No water vapor and no rainfall. That means temperatures shoot up during the day and drop like crazy at night. The K2 exoplanets, like the most extreme parts of all of our solar system, all rolled into one scary planet. But we're not headed there anytime soon. We haven't even been to Mars yet. That's all way off in the future, and 200 light years is a really long travel time. If we're going to move anywhere anytime soon, we'll probably want to set up camp on the moon. No magma oceans, no warp speed winds, nice temperatures. So, where would we even start? Well, the main issue is that drones and remote control robots are getting more and more advanced. It's way cheaper to send them over to map out the moon for us while we're safe here on Earth. And if we ever want to begin space exploration for real, we'd need a proper space base. And what better place than our little shiny moon? So, why do we even study those far-off planets? What's the point? Well, planets are like people. They're all different ages and live in all different places. The more of them we study, the more we can understand why there's life, aka us, on Earth and not on any other planet so far. When we see crazy new planets, we get crazy new ideas, which can turn into awesome inventions that make our lives easier. Even just going into space gives us new ideas. Scratch-proof lenses, some firefighting equipment, water filtration systems, wireless headsets, invisible braces, that tiny vacuum you use to clean those crumbs in from between your couch cushions, they were all invented to help astronauts work better in space. And now they make our lives better every day. Maybe we'll figure out a new energy source someday, thanks to a far-off planet or star. Or we might discover a new compound that will make our buildings stronger or more energy efficient. Okay, quick space riddle. Why is the search for life in the universe like a tree? Because you're always looking for a place to plant it. You know, plant it, planet. Okay, settle down. Anyway, water is the basis of life in any part of the universe, so potentially inhabited planets must have liquid water on them to support life. An incredible number of circumstances must come together for this. The planet must be in the habitable zone of the star. Then the temperature and atmospheric pressure on the planet's surface will be suitable for simple life forms to begin to evolve. A little closer to the star and the water will evaporate, leaving no chance for oceans and seas to form. This is what happened on Venus. It has a size and mass similar to the Earth, but it's too close to the Sun and no life can exist on its surface. Too far from the star, and the planet becomes too cold. Water can only exist in the form of ice on the surface, and there just might be liquid water deep below. Neptune is one example of this. In addition, the planet must be solid and have an atmosphere that protects it from solar radiation and allows living organisms to breathe. In our galaxy alone, there are countless stars. Really, you can't count on them. Near each one of them may be a planet. They're called exoplanets, and some of them may be in the habitable zone and have everything for life to form on them. From a list of 4,500 known exoplanets, scientists have identified 24 that can be superhabitable. This is the type of planet that is suitable for the existence and evolution of life even more than the Earth. Such planets must be twice as massive as the Earth and 1.3 times larger. A bigger size means stronger gravity and a denser and warmer atmosphere. This will ensure a greater diversity of all living organisms on the planet. In addition, we should pay attention to the host star around which the superhabitable planets will orbit, and there should be a McDonald's nearby. Ideally, it should be smaller than the Sun and have a lifespan of at least 15 to 30 billion years. For comparison, the lifespan of the Sun is under 10 billion years, and it took about 4 billion for complex life forms to appear here. Stars such as the Sun can simply run out of fuel before life can develop on its exoplanet. Scientists suggest focusing on dwarf stars. They're smaller and less luminous than the Sun, but their lifespan can be between 20 and 70 billion years. This will give living organisms enough time to develop and evolve. Climatic conditions on superhabitable planets will also be different. The average temperature should be 8 degrees Fahrenheit higher than on Earth, and there should be more water in the form of clouds, liquid, and humidity. These conditions are the most favorable for biodiversity, so the whole planet would be looking like tropical forests on Earth. All 24 candidates for the title of Better Than Earth, are more than 100 light-years away from us, and with the advent of the new generation of telescopes, we'll probably be able to find out exactly if there is life there and if the conditions there are suitable for humans. Now, let's take a look at the potentially inhabited exoplanets. Teegarden B. It's an exoplanet that orbits a red dwarf star about 12 light-years away from the solar system. Typically, red dwarfs can emit flares that blow away the atmosphere of the planets in its orbit. But this host star is calm and relatively passive. Teegarden B has almost the same mass as the Earth. It makes a complete circle around its star in about 5 days. Yep, you got it right. A year on Teegarden B is less than a week on Earth. Hold on to your hats. The furthest potential inhabited planet is Kepler 1638b. It's in the constellation Cygnus, about 3,000 light-years away from us. It belongs to the Super-Earth class. It's twice as wide and 4 times as heavy as our home planet. The gravity on it will feel much stronger. Even a normal jump will be much harder for you than on Earth. Although, if this planet is really inhabited, local life is used to such conditions. LHS 1140b. This planet is very rocky and solid. Although its size is only 40% larger than the Earth, it's 7 times as massive. It has a strong gravity of 3.25 Gs. For comparison, when you take off on an airplane, you experience an overload of about 1.5 Gs. So on this planet, you'd barely be able to stand on your feet. Because of its large mass, this planet has a thicker atmosphere, and because of the greenhouse effect, its temperature can be above 19 degrees Fahrenheit, and it rotates around its star quite quickly. It makes a full circle in just 24 days. And now, let's look at the constellation Aquarius. Here's an ultra-cold dwarf, TRAPPIST-1. A small planet orbits in its habitable zone. It's 3 times lighter than the Earth. Its temperature is similar to ours, but the gravity is half as weak. But we would still feel comfortable there. Remember the people that went to the moon? There, the gravity is only 16% of the Earth's. That's what makes the astronauts move so funny. Kepler 452b is in a system that resembles the older sister of ours. The host star is only 11% older than our Sun and is almost 2 billion years older. The exoplanet itself is 6.5 billion years old, compared to 4.5 billion of Earth's. But these sisters are very far from each other. If you travel at the speed of the New Horizons spacecraft, it will take about 26 million years to get there, so bring a big lunch. This is the closest exoplanet to us, Proxima Centauri b. It orbits the red dwarf Proxima Centauri, which is the closest star to the Sun. This planet is just 4.2 light-years away from us. Its size and mass are very similar to those of the Earth. It probably has an icy structure, like Neptune. Although Proxima Centauri is the closest star after the Sun, we can't see it with the naked eye because it's too dim. So, all these planets, including the 24 that scientists have recently found, are in the habitable zone of their host stars. And, in theory, we can colonize them and make them suitable for human life in the future. But here we'll have to solve one big problem. Even the nearest exoplanet is too far away for us today. Our modern rockets can fly at 5 times the speed of sound, and even at such speeds, it will take us more than 100,000 years to get to Proxima Centauri on one of them. Well, we need to come up with something a bit faster to travel to a new home on one of these exoplanets. And perhaps scientists already have the answer. Warp drive. Ooh. This is a piece of technology that will allow us to manipulate space and time. It creates a kind of a bubble in which the normal laws of motion don't work. So the spacecraft will be able to significantly exceed the speed of light. And this isn't science fiction. Humanity already has such technology, although just in theory yet. It's Alcubierre warp drive. And no, I didn't make that up. Since no object that has mass can travel at the speed of light, we need to do one trick. The spacecraft has to move by compressing the space in front of it and expanding it behind it. Thus, not only the ship is moving, but also the space-time inside this warp drive bubble. And the maximum speed can be 10 times that of light. But to warp the space-time, the ship must be incredibly large, and to power it, we'll need the amount of energy close to what the whole planet of Jupiter generates. Still, recent calculations of NASA's Jet Propulsion Lab show that the ring around the ship, which should create the so-called warp field, shouldn't be perfectly round, as it was thought before. It can be more donut-shaped. Ah, donuts. This will greatly simplify the design and construction, and will make it possible to test this technology on a spacecraft the size of a Voyager 1 probe. Even though it still seems impossible, scientists are already saying that there is hope. And while we don't know what technology will be used, in 2069, NASA plans to launch its first interstellar mission to explore potentially habitable planets outside of our solar system. Various rumors say that the speed of light can be achieved with laser technology. If the probe is very small, it can be launched to the Alpha Centauri star at almost the speed of light. There are also 2 other alternatives to power spaceships. These are nuclear energy and energy from matter and antimatter collisions. Ooh! These technologies are still a mystery to humanity, though. Well, for the time being, stay tuned. TRES-2b is a planet where night never ends. And it's not your regular night with stars shining in the beautiful skies. Here it's pitch dark and scorching hot. TRES-2b is a gas giant, roughly 1.5 times more massive than Jupiter, and its surface absorbs light better than charcoal. It might also have a faint dark red glow because of its burning air, which is as hot as fresh lava. Lovely. In the star system of 55 Cancri, there are 5 planets, 4 of which are gas giants similar to Jupiter and Saturn. But the 5th one, or rather the first because it's closest to the star, is different in a most horrible way. 55 Cancri e is so close to its sun that half the planet's surface is a literal ocean of molten lava. The other half is in eternal darkness because it never sees the sun. The planet is always turned to its star on one side, and between the scorching and the dark, there's the twilight zone, a thin strip of gloomy nothingness. HD 189377b, I'm not going to say that again, is the only exoplanet in the orbit of its star, and at first glance it looks quite pretty, blue and white swirls making up wondrous patterns on the surface. But these pleasant colors actually come from hard silicate particles in the planet's atmosphere, which means it rains glass here. But the worst is that winds reach the speed of 5,400 miles per hour, or almost Mach 7. Well, for comparison, the fastest wind speed on Earth was 254 miles per hour, over 20 times less. Thus, the glass falling from the sky travels horizontally at hypersonic speeds, shredding everything in its path. The next system, whose name I won't even try to pronounce, this one, has 3 exoplanets, which are all being slowly destroyed by their own star. It happens because that star is not a regular. It's a pulsar, a rapidly spinning core of an exploded star. It creates powerful electromagnetic pulses in several directions while rotating at several thousand times per second. As a result, the planets orbiting this deceased star are slowly being eaten away and will eventually disappear entirely. Kepler-70 is a hot blue dwarf star that exploded into a red giant some 18 million years ago. At the time, it was orbited by at least 2 planets, the closer of which was a Jupiter-like gas giant. Its name was Kepler-70b, and it still exists, but the overgrown star consumed it and transformed it into a blazing hot rocky world. Right now, it's one of the hottest planets ever discovered. Its temperature is higher than the surface of our Sun. It was lucky to survive spending time inside the star, but it's evaporating now and will probably be no more in the near future. WASP-12b is one of the weirdest and saddest planets out there. The enormous gravity of its star, combined with the planets consisting mostly of gas, result in the star slowly devouring its protege. WASP-12b has already taken the form of an egg, stretched toward its merciless sun, and it's unable to do anything with its condition. In another 10 million years, the planet will inevitably succumb to the voracious star's appetite. If you ever wondered what it's like to walk on ice and hot coals at the same time, Gliese 436b is a planet that would give you a vivid example. Being extremely close to its sun, the Neptune-sized exoplanet boasts temperatures hotter than a blazing oven, and yet it's covered in ice, which burns incessantly. This ice is much denser due to the enormous gravity of the planet, staying solid even under extreme conditions and not melting away. No list of frightening worlds could do without mentioning Venus, the Earth's evil twin. The second planet from the Sun has an atmosphere so thick and full of clouds that its surface is much hotter than that of Mercury. Volcanic eruptions constantly thrash Venus. Its gravity is almost 100 times stronger than ours, and those clouds I mentioned are not made of water but of sulfuric acid, which condenses and rains down on the ground, adding to the inferno. But even if you were brave, or crazy, enough to try to pass through these clouds, you probably couldn't. The winds up there are as strong as some of the most powerful hurricanes back on Earth. Here we have a very long name for a very, very cold planet. Although the host star is not too far away, it's a small and rather cool red dwarf, whose light and heat barely even reach the planet. The temperatures out there fall as low as minus 370 degrees, which is only marginally warmer than absolute zero. The exoplanet is thus dark, gloomy, and covered in eternal ice that never thaws. Still, if it has a rocky core, it might generate some heat, so there's a chance that deep below the frozen surface, some unknown alien things might lurk. Dimidium, located roughly 50 light-years away from our solar system, is a planet hostile to any living thing on many accounts. It's tidally locked to its sun, which means one of its sides is always facing the star, while the other is always turned away. The hot side is heated to over 1,800 degrees, perpetually blown over with winds reaching 600 miles per hour. Despite Dimidium being a gas giant, it has a large amount of iron in it, which melts and evaporates in the atmosphere, creating clouds. And when those cool down, they fall on the surface in the infernal rain of molten iron. Oxygen is usually viewed as an element that might bring life to a planet, but this is definitely not the case for Osiris. Scientists were shocked to find oxygen on this planet, or rather around it, because it's 8 times closer to its star than Mercury is to the Sun. This extreme distance makes Osiris a living melting pot, where anything that could burn will. It's also responsible for a very short orbit of the planet around the star. A year on Osiris is just 3.5 days on Earth. To boot, the atmosphere of the planet is constantly blown and melted away by the heat from its sun. Karat XO 3b is neither as hot nor as cold as some of the others on this list, but it's terrifying in its own more insidious way. It's a gas giant similar in size to Jupiter, yet 20 times denser. This makes this exoplanet's gravity weigh down on everything on its surface 50 times more than it would on Earth. Stepping on it would be your ultimate doom, because you'd be immediately crushed by the density of its atmosphere. Karat 7b is another oven-like world. Its day-to-day temperature is over 4,000 degrees. Combined with the rocky surface, it presents an infernal landscape. The rocks on the ground bubble and boil, evaporating in the atmosphere, where they cool down and eventually fall back on the surface in a brimstone rain. The saddest thing about Karat 7b is that it might have once been a gas giant whose atmosphere melted away from the heat, leaving only the scorched core. We're used to thinking that asteroids are the only free-floating rocks in space, but things like OTS-44 make you think twice and shiver. Imagine a planet about 11 times more massive than Jupiter roaming in space without being bound to the orbit of any star. Given its gargantuan size and mass, if OTS-44 collides with any other planet, it would utterly destroy it and go on floating as if nothing happened. Scarier still, scientists are sure there are millions of such rogue planets out there, just waiting to be discovered. There's no hard proof of their existence yet, but theoretically, carbon planets have formed somewhere closer to the center of our galaxy. Any oxygen getting in their atmosphere would get into a reaction with carbon and transform into CO2, forming black toxic clouds. On the ground, there would be oceans made of tar, spewing up geysers of methane and crude oil. There would be rains too, but they'd be far from refreshing. Torrents of pure gasoline and hot liquid asphalt would blast the ground and probably burst into flames on impact. Hard to imagine anything that would survive such conditions.
The Sun is getting ready to flip as its magnetic poles are reversing. Similar to Earth, the Sun has a magnetic north and a magnetic south. But unlike Earth, the reversing process of the Sun's poles is more frequent and easier to predict. The next flipping is expected to take place this year between April and August. As apocalyptic as it might sound, you don't have to worry. If you're around 30, you've already experienced this phenomenon more than once, as the Sun flips every 11 years. You probably didn't notice any changes back then because this process doesn't impact Earth's life so much. But this time, things might be a little different. On Earth, ocean currents are movements that play a crucial role in influencing both climate and weather by distributing heat from the equator to the poles. On the Sun, these currents are more like an ocean of plasma, but they not only transport heat but also carry electromagnetic energy. That happens because the Sun is a huge ball of hot and ionized gases that keep flowing inside its core. By fusing together hydrogen atoms and forming helium, our star releases a massive amount of energy, leading to these very heavy flowing electric currents. And whenever you have currents, you have magnetic fields. It's easier to understand if you think of that classic experiment with a wire and a nail that you probably conducted in elementary school. When electricity flows through a wire, it creates a magnetic field around the wire. So when you connect a wire to a battery and wrap it around a nail, the nail becomes a magnet. This is similar to how electric currents create magnetic fields on the Sun. This whole process, with the help of which the Sun generates its magnetic field, is called a dynamo. We can't observe it directly, but we can see its effects on the Sun's surface. When plasma and magnetism flows become unstable and intense, they manifest as sunspots. You know, those dark areas on the Sun's surface? Much about how the dynamo works remains a mystery. But scientists have learned something important after observing these sunspots for centuries. The dynamo process follows a pattern. About every decade, it reorganizes itself. The sun's polar magnetic fields get weakened, eventually reaching zero, and then they return, but with the opposite polarity. Back in the 50s, researchers figured out that when sunspots start to ramp up and become more intense, it means the poles are gearing up for a reversal. And over the past few years, solar activity has been off the charts. We're talking about more solar flares, more electromagnetic radiation bursts, and more plasma blobs being ejected into space. It's like we're sitting in the front row at the solar system's most epic fireworks display. In fact, the sun hasn't been this lively in probably 2 decades. Right now, experts think the polar fields are almost in sync and steadily weakening, inching closer and closer to zero. But we haven't reached the point of reversal yet. Although it might sound like the sun flips its magnetic poles like clockwork every 11 years, the truth is that it's not as neat as it seems. This path can be bumpy, and some aspects of the phenomenon are still very hard to predict. Take the last solar cycle, for example. The Northern Hemisphere started its magnetic flip back in early June 2012, but then it kinda hit a snag and lingered around the neutral point until late 2014. Meanwhile, in the Southern Hemisphere, things were smoother, with the polarity switching over in mid-2013. This time around, the sun is actually playing nice. Things seem to be running way smoother this cycle, with the poles transitioning more evenly. But here's the thing, reversal processes are never the same. That's what makes this phenomenon so interesting to observe. But at the same time, it's hard to predict how it'll affect us down here. Here on Earth, we don't have to worry too much about those intense sun explosions happening 93 million miles away. But if, and I emphasize if, a solar storm were to reach our planet, the main threat it would bring would probably be the disruption of communication satellites in space. However, things might be different in this cycle reversal happening in 2024 because the number of satellites has skyrocketed in recent years. For example, Elon Musk's Starlink system alone involves more than 4,000 of them. All these satellites, along with communication and GPS satellites, could be impacted or even destroyed by a powerful solar storm. Although the chances of a powerful solar storm hitting Earth are low, it's not impossible. Back in 1859, during the Carrington event, a storm occurred near the peak of the solar cycle, causing currents to surge through telegraph lines, sparking fires and disrupting messages worldwide. Earth fell silent as telegraph communications failed. Just imagine what a solar storm could do to our vast number of satellites today. It could affect everything we rely on daily, from space-based communication and navigation to weather forecasting services. The ground-level power distribution could also be affected. You can forget about watching YouTube or Brightside, because if such an event occurred today, it would cause an internet apocalypse, sending countless people and businesses offline. There's a prediction that says that if a Carrington-class event happened today, it would result in damages ranging from $0.6 to $2.6 trillion. And I'm talking about the United States alone. Fortunately for us, solar storms as intense as the Carrington event happen only once every 500 years or so. Bad news for communication satellites, but great news for aurora watchers. During the Carrington event, dazzling auroras borealis lit up the sky as polar light shows stretched far beyond their usual ranges. The northern lights were spotted as far south as Cuba and Honolulu, Hawaii, while the southern lights were seen as far north as Santiago, Chile. For many people around the world, this was their first glimpse of the aurora, leaving them obsessed with the unusually bright skies. Some of them thought it was the end of the world, while others began their day early, thinking the sun had risen after hearing birds chirping and seeing the bright skies. Today, we know there's nothing strange about it, considering that the appearance of auroras at lower altitudes is one of the expected effects of the sun's magnetic pole reversal. Typically, these dazzling phenomena are found between 60 and 75 degrees latitude, but during the last magnetic pole reversal in 2013, intense auroras were observed below 50 degrees. Eyewitnesses describe these auroras as blood or deep crimson red, shining so brightly that you could read a newspaper in their light.
It's important to study this phenomenon and not to fear it. The inversion of the magnetic poles on the Sun is actually a great opportunity for scientists to better understand how our star works. Since many pieces are still missing in the whole dynamo situation, we're still not very good at predicting why some solar cycles are more intense than others, or when exactly a coronal mass ejection will erupt. But being able to predict that is becoming more and more necessary as we venture ourselves into space. The more people are out there beyond Earth, the more exposed they are to these strong solar storms. That's why the scientific community wants to know more precisely when a solar storm can cause damage to spacecraft and space stations. Plus, it would help meteorologists make progress in predicting weather, not only on Earth, but also in space. The whole point is to make space travel safer as the interest in crewed missions to the Moon and Mars grows every year. Another reason why it's important to learn more about the Sun's pole inversion is to better understand how the mysterious interior of the Sun works. That could actually help us figure out the aspects of other stars in the universe and maybe get closer to answering the ultimate question: why are we here?
We still can't find the source of the mysterious signal we've been receiving since 2018. We receive it every 22 minutes and nothing can explain this. Some scientists even believe it could be coming from another civilization we haven't met yet. This strange radio signal wasn't found by a scientist on a serious mission. It was actually discovered by a college student just doing a regular project for school. Tyrone O'Doherty, an undergrad student at Curtin University in Australia, was sifting through old data of the southern sky. He was looking for any weird blinking radio signals. He finally stumbled upon one from 2018 that seemed to shoot radio waves towards Earth like a lighthouse beam. Excited about his find, Tyrone shared it with his mentor, radio astronomer Natasha Hurley-Walker. She dove into researching this signal, hoping for a breakthrough. But despite checking different frequency data, they hit a dead end. But then, Natasha spotted a pattern. The signal repeated every 18 minutes. This was huge. But just as they were gearing up to study it further, poof! The signal vanished after only 3 months, leaving them with nothing. Not giving up, Natasha and her team scanned the skies again, desperate for a clue. Months passed, but nothing turned up. They were ready to give up, and then suddenly, a new signal popped up. This one kept blinking for 5 minutes, then it disappeared. And then it came back exactly 22 minutes later. The main question was if that signal was related to an 18-minute one. To figure it out, Natasha went back to the old radio data from that area. As they dug deeper, they realized that yes, and these signals aren't anything new. They've been beaming towards Earth for 35 years. Back in 1988, Indian and American telescopes had caught them, but they got buried under tons of other data. This was great news for space explorers because it meant they could now calculate how far away this mysterious object was. After doing the math, they figured out it was incredibly far, even on a space scale, 15,000 light-years from Earth. Now, the only thing left to uncover was what exactly this object was. Walker and his team started comparing it to all the known radio-emitting objects out there. Yet its source remains a mystery. The signals still pop up every 22 minutes on NASA screens, always ending with a frustrating match not found message. The scientists called it J183910. Some think that the signal might come from some extraterrestrial beings. Maybe it's the signal that SETI, the search for extraterrestrial intelligence, has been waiting for. This project has been working for over 50 years, trying to find any evidence of life beyond Earth. They also scan the skies for radio waves, laser pulses, and other mysterious signals. So maybe it's a way for extraterrestrial folk to communicate their location. While that idea may sound exciting, we need to be careful about jumping to conclusions. First, we don't have solid proof for that. Before any concrete evidence, it's just speculation. And also, there are other more plausible explanations. Most likely it comes from a natural phenomenon, and there are a couple of theories for that. The first one is the pulsar theory. Imagine a huge star in space much bigger than our Sun. Sometimes these big stars finish their life journeys in a spectacular event called a supernova. When this happens, the star's core collapses, becoming super compact, as if you're squeezing all the stuff from that star into a tiny space. That tiny, super-dense core is called a neutron star. Some of these neutron stars are extra special. We call them pulsars. They get their name because they seem to pulse with energy, like a space lighthouse. These pulsars have incredibly strong magnetic fields, much stronger than what you'd find on Earth. They're like enormous magnets in space. Because of this, they shoot out beams of energy. They're also spinning super fast, so these beams of energy seem to pulse on and off as they spin around. Now, the strange signal we detected seems to have similarities with pulsars, but not quite. Pulsars usually have a predictable lifespan and slow down over time, eventually stopping their radio signals. In contrast, our mysterious signal is quite persistent and is blinking beyond what's expected for pulsars. So, maybe it's not a typical pulsar, or not a pulsar at all. There's also a magnetar theory. Now, a magnetar is another type of neutron star. They're like supercharged versions of pulsars, with even stronger magnetic fields and slightly longer pulsating periods. Maybe this is what causes our signal's intense persistence. However, when we plotted the data, we also realized the signal didn't match the magnetar's vibes either. Magnetars not only send out radio waves, but also powerful X-rays because they're so energetic. But the signal we received was only sending out radio waves. So we figured it's not a pulsar and not a magnetar. The signal's behavior is very strange and suggests an unnatural source. This means there might be something in the universe that scientists haven't fully explored yet. And there is a space object that we don't know much about. The final theory is the so-called dwarf pulsar. Sounds a little dopey to me. Couldn't help myself. Now, a dwarf pulsar is like a star that blinks with light flashes, similar to pulsars, but it takes longer for each blink. Usually, white dwarfs are the leftovers from smaller stars. They don't blink because their magnetic field isn't as strong as pulsars. But when a white dwarf becomes pretty hefty, almost the mass of our Sun, it gets super dense and starts pulsating with a strong magnetic field, just like pulsars. They have a cool quirk. White dwarfs are made of electrons, not neutrons like pulsars. When these charged electrons start dancing with a magnetic field, they shoot out periodic light flashes, which happen every 100 to 1,000 seconds. As you remember, our signal has a period of 22 minutes, 1,320 seconds, a bit longer than the usual white dwarf pulsars, but it's much closer to the truth. So far, this sounds like the most plausible explanation. But even this theory isn't fully confirmed yet. This just shows how much there is in the universe that we're still figuring out. For example, fast radio bursts, another mysterious type of signal we've been detecting. They're like quick, intense bursts of energy in the form of radio waves. They have a ton of energy. FRBs are so powerful that sometimes they can be brighter than entire galaxies. Now, imagine this. They release as much energy in a few milliseconds as our Sun does in 3 whole days. Wow! These bursts happen all over the sky with huge frequencies, although some have been detected with lower frequencies. Every day, we catch around 10,000 random FRBs in the sky. Some of them repeat, but most happen once and disappear forever. Unfortunately, most of them only last for a fraction of a second, and by the time their energy reaches us, it's 1,000 times weaker than a mobile phone signal from the moon. This is why, despite their brightness, there's still a lot we don't understand about them. We're still trying to figure out what causes these FRBs. They could be coming from different sources, like already mentioned magnetars, colliding stars, or even merging galaxies or white dwarfs. As these bursts travel through space, they pick up information about the cosmic environments they pass through, like interstellar gas clouds. It's very unlikely that FRBs are some messages from extraterrestrial beings, though. Not only because there are thousands of them every day all across the sky, but also because we know that the sources of these bursts must be incredibly energetic themselves. Our neighbors would have to have equipment stronger than entire galaxies for that. But the bottom line is, while all these signals are fascinating, there's still a ton to learn about them. Now, Jupiter used to be flat and look like an M&M candy. Now I'm hungry. And it wasn't the only flat pattern in our solar system. Turns out there are tons of things that can go wrong during a planet's formation, like locking up to the sun or getting whooshed into open space. Let's check it out. The Earth isn't flat, but Jupiter might have been. Instead of being a big round ball, gas giants in our system might have started more like flat pancakes. Jupiter is one of the oldest of our neighbors. It's 4.6 billion years old, just like our Sun. And when it was just a baby planet, it likely formed through a process called disk instability. It all begins with stars. When a star is forming, it doesn't look like a round object. It's more like a big disk of stuff. During this stage, really hot winds made of charged particles blow out. The dust in that disk contains stuff like carbon and iron. Some of them collide and stick together, forming bigger objects. Dust turns into pebbles, pebbles turn into rocks, and rocks bump into each other, getting bigger. Gas in the disks helps all these solid bits stick together. Some break apart, but others stick around, and they're the ones that become the basic pieces of planets. They're called planetesimals. Even gas giants like Jupiter started off as tiny specks of dust, smaller than a human hair. Eventually, they formed their own big ring-shaped disks of gas. They began to spin around our sun, growing bigger by gathering gas and rocks like snowballs. Gas giants are special. They were born from the colder parts of the disk. In cold areas, molecules are slower, which makes them easier to grab. In these places, water could freeze, and tiny ice pieces stick together and are mixed with dust. These dirty snowballs gather up and then form cores of huge planets, like Jupiter, Saturn, Uranus, and Neptune. In the warmer areas closer to the star, rocky planets like Mercury, Venus, Earth, and Mars start to form. After the icy giants were born, there wasn't much gas left for these smaller planets. It might take tens of millions of years for these rocky planets to form after the star is born. And our sun was growing at the same time, sucking up nearby gas and pushing faraway stuff even farther out. After billions of years, the disk changed completely, turning into a round star with a bunch of planets, dwarf planets, asteroids, moons, meteoroids, and comets around it. Recently, simulations showed that these protoplanets, as these early dust balls are called, don't start off looking like the planets we know. In the case of gas giants like Jupiter, they look more like squashed balls or M&M's candies, not the peanut kind. When the sun was young, the disk of gas and dust surrounding it cooled down and became unstable. It started breaking into big chunks. These chunks dramatically collapsed together under huge gravity to create Jupiter. It became a round gas giant over time. There are a lot of oddities that can happen during that process of planet formation. Ever wonder why Venus or Uranus spin in the opposite way compared to other planets? Usually, when things form from a spinning disk of gas, they tend to spin in the same direction. For example, if you spin a bunch of balls on a string, they all twirl in the same way. So, theoretically, all planets should spin in the same direction too. But there are a lot of fast-moving objects, like comets and asteroids, in our solar system. When they smash into planets, especially during their early days, this collision might send the planets to spin in the opposite direction. Venus and Uranus probably survived a massive collision. Luckily, they weren't repelled to outer space. The gravity from the Sun and nearby planets pulled them back into place. There are also so-called tidally locked planets. These are celestial bodies that spin in a way where one side always faces their star while the other side remains in perpetual darkness. So one side is always very hot while the other is extremely cold. If we were on a planet like that, we would only be able to live on a thin line in between. These planets form when they're very close to their star. The gravitational forces are extremely strong, and over time, these forces slow down the planet's rotation until it matches the time it takes to orbit the star. Imagine you're spinning in your chair. Someone comes up to you and, holding onto your chair with their hands, starts spinning with you. This way, you'll always face each other. Tidally locked planets kind of work like that. Our moon is tidally locked to our Earth, which is why we only see one side of it. We've discovered more than 5,000 planets outside of our solar system called exoplanets. Some of them have very strange orbits. For example, planets with incredibly long orbits, thousands of years to make one trip around the star, or very wonky, comet-like orbits, or so-called hot Jupiters. They're super close to their star, way closer than Mercury is to our Sun. But these planets couldn't have formed where they are now. As their solar system evolved, they changed their positions for some reason. This rearranging is called planetary migration. There are three main ways this migration happens. First, because of the gas and dust spinning around the planet. When a planet is bumping into this stuff, it can create spiral patterns in the gas. These patterns can either push the planet closer to the center or farther away, depending on how they mix together. It's called a gas-driven migration. This is what Jupiter experienced when it moved closer to the Sun billions of years ago. I wasn't around then. This also explains the existence of hot Jupiters. Second, big planets can shove the smaller ones, changing their paths. Third, the star's gravity can tug on the planet, making its orbit more circular. Ever heard of rogue planets? Imagine a lonely planet floating in the vastness of space without a star to call home. They're like the wandering nomads of our galaxy, doomed to drift around forever. And there are so many of them, there might be more free-floating planets than ones that are tied to stars. We're talking trillions of rogue planets hanging out in our Milky Way galaxy alone. They're often as massive as our biggest planet, Jupiter, but most of them might be Earth-sized. Some might even have thick atmospheres that keep them warm, even though they're far from any star. Some of them might have wild auroras, while others could host moons with liquid water, a potential haven for life. There's even a chance that they might contain extraterrestrial life. These planets might bump into other stars or even entire planetary systems as they journey through space. Sometimes they might get caught in a star's gravity for a while before getting flung back out into space. But how are they born? Sometimes, during this chaotic process of planet formation, not all planets can manage to stay close to their parent stars. Some of them get kicked out of their solar systems due to powerful gravitational interactions with other planets or passing stars. These ejected planets become rogue planets. In 2012, astronomers found a solar system from the very beginning of the universe. This system included a star and two planets. We called it a fossil system. The star is super old, about 13 billion years, almost as old as our entire universe. It was mostly made of just hydrogen and helium. This is unusual because planets usually form from clouds of gas that contain heavier stuff. That's when we figured out that the way planets formed before was different from how they form now. We know that stars with more metals are more likely to have planets. In astronomy lingo, metals means any chemical element other than hydrogen and helium. But in the early universe, there weren't many metals. Most of them were created inside stars and then spread out into space when those stars blew up. So, when did the very first planets form? This newly discovered system helps answer these questions. Its two giant planets are orbiting a star that's incredibly low in metals and extremely old. This should be really rare, if not impossible, but they exist. This means that maybe there are more planets in metal-poor systems than we thought. Studying them will help us learn more about the history of planet formation.
If the multiverse theory is correct, ours is not the only one out there. Which is as interesting as it is scary, right? Now, not every scientist is on board with this mind-bending concept. And let's be honest, the idea of actually making contact with these parallel universes sounds about as probable as winning the lottery while riding a unicycle. But hold on tight, because this strange concept isn't just limited to the realms of fiction anymore. Believe it or not, a bunch of scientific theories actually support the existence of parallel universes. And let me tell you, it's a topic that stirs up quite the debate in scientific groups. Now picture this. The universe we live in is mind-numbingly vast. We're talking billions, some say even trillions of galaxies swirling around, each packed with an almost uncountable number of stars. Some brainiacs studying the universe's shape suggest that its diameter could span a staggering 7 billion light-years. Others even argue that it might be infinite. Could there be more out there than meets the eye? Well, real scientific theories are exploring the possibility of universes existing alongside, beyond, or even mirroring our own. These intriguing concepts of multiverses and parallel worlds often intertwine with other, more familiar scientific ideas like the Big Bang, string theory, and quantum mechanics. In order for us to figure out what's out there, we have to rely on the information we're a bit more confident in, right? Let's rewind the cosmic clock about 13.7 billion years ago. Everything we're able to see today was squished into a minuscule singularity. Then, if the Big Bang theory is to be trusted, it all went boom. The universe inflated with a speed faster than that of light everywhere, within less than a second. The way the universe went pop has led some clever researchers to ponder the existence of more than one universe. They question whether that sudden growth ended everywhere at the same time. While the expansion ceased for everything we're able to see from Earth 13.8 billion years ago, cosmic inflation might still be ongoing in some other mysterious corners. Some theoretical physicists say that as inflation ends in one place, a new balloon universe forms. But here's the catch: you can't just hop from one bubble to another like intergalactic tourists. These bubble universes are expanding indefinitely, and their edges are zooming away from us faster than light can travel. And here's where things get even more confusing. Let's say we somehow manage to reach the edge of our local balloon and encounter the next universe. Well, those same theoretical physicists mentioned that the neighboring universe could be a whole different ballgame. It might have completely different laws of physics, making it a bizarre place for us. Following the same idea, some say that in this vast multiverse of bubble universes, there might be other life forms just like us. The problem is, we're getting farther away from them with each passing moment, and our paths will never cross. Other super smart researchers out there are trying to connect parallel universes with quantum mechanics. Now, quantum mechanics is basically the fancy math behind teeny tiny particles. According to it, these particles can exist in multiple states all at once. They call it a wave function that holds all the crazy options. But here's the catch. When we observe these particles, we only see one outcome. It's like the universe keeps playing hide and seek with us. Now, there's this theory called the many worlds theory that says whenever we observe one outcome, another universe pops up where a different outcome becomes real. It's like our universe acts as a giant tree, constantly branching into countless versions of itself. These alternate universes can't mingle, though, so you wouldn't even know if there are a bunch of other yous living slightly or totally different lives. This many worlds theory is pretty bold and a bit hard to prove or disprove. And that's not great for science because scientists love to test and experiment with their ideas. But if there's infinite space out there, why wouldn't there be infinite universes too? Try to imagine the universe as this giant cosmic playground. Some specialists believe that if it's indeed never-ending, then there's only a limited number of ways that its building blocks can arrange themselves. Eventually, they have to repeat certain patterns. If this is true, then it may be possible that somewhere out there might be another version of you living the exact same life, even down to what you had for brunch yesterday. Did we ever have any proof of these supposed parallel universes? Well, some say we did. Have you heard the tale of the mysterious man from Taured? It's the story of a man that ended up at a Japanese airport saying he was from a totally unknown country called Taured. Now, some folks think it's proof of time travel, while others believe it's evidence he came from a different universe altogether. As much as you'd like to believe the story to be factual, the tricky part is this Taured place. There's a reason you haven't heard of it. There's no Taured to be found, whether in the present day or back in the 1950s when this supposed incident happened. After the airport incident, the man just vanished into thin air a day after arriving in Japan. Poof, gone forever. Let's rewind to that fateful day in July 1954 when the man from Taured supposedly landed in Tokyo. Descriptions paint him as a bearded, French-speaking man. Nothing too outlandish so far, right? Depending on who's telling the story, things start to diverge a bit. In one version, when the man hands over his passport to get stamped, the Japanese officer's eyes bulge out. While the passport looked legit, the country listed as Taured isn't recognized by anyone, including the officer and other officials. Naturally, they take our Taured visitor away for a little Q&A session. In another version, the man straight up tells the officer he's from Taured and shows him the passport when he doesn't buy it. Our man from Taured then started trying to convince the officers that his homeland is the real deal. According to him, Taured sat snugly between France and Spain and would have been around for about 1,000 years. To prove his point, he even points to the area on a map that matches the Principality of Andorra. Obviously, things took a mysterious turn. The officers decided to hold the man in custody, suspecting he might be up to no good. They put him up in a nearby hotel for the night, but not without stationing 2 people outside his room to keep an eye on things. Can you guess what happens next? Drumroll, please. When the officers showed up the next morning, ready to continue their investigation, the man had vanished without a trace. No sign of escape, and to make matters even more puzzling, all his personal documents have magically vanished too. What if the man from Taured was a time traveler or an intergalactic adventurer? Some have even delved into the realms of science fiction to explain this bizarre event, and you won't believe the number of people on the internet who've latched onto it as evidence for alternate realities. One of the weirdest ideas suggests that the man accidentally stumbled into a parallel dimension and ended up at the Japanese airport. In that parallel universe, there's an Earth just like ours, but instead of Andorra, they call it Taured over there. Another idea floating around was that the man was a time traveler from the future. Sorry to break it to you, but the most reasonable explanation for the whole story of the man from Taured is that someone's imagination went wild. Since there are many versions of the same story, it's probable people just kept adding outrageous details to the case, to make it more sensational. The whole story simply snowballed into an urban legend, and there's little to no reason to believe we've once seen a time traveler or intergalactic hitchhiker right here on Earth. It's been more than a year since the James Webb Telescope, which had taken over 20 years to complete, was launched. And for such a relatively short time, the ultra-modern and most powerful in history piece of equipment has already made plenty of discoveries. By observing the universe at infrared wavelength, James Webb lets us see things no other telescope has ever shown before. The primary goal of this incredible piece of equipment is to study the formation of galaxies and stars that appeared in the early universe. For example, look at the closest to us stellar nursery, a region of space where new stars get born. NASA has shared an image from James Webb that shows a small star-forming region. If you look at the picture attentively, you'll see jets bursting from infant stars. Around them, different colored clouds of cosmic dust are colliding with one another. The view is mesmerizing. The red dust consists of molecular hydrogen. You can also notice that some stars have something like shadows. Those hint at the creation of what will later become planets. At first sight, the image may seem chaotic, but astronomers claim that it's a relatively small and quiet stellar nursery in comparison to some others. Many young stars there are similar in size to our Sun, or a bit smaller. The photo itself was taken with the help of Webb's near-infrared camera, NIRCam. It's the observatory's primary camera that snaps images of the cosmos in 2 different infrared ranges. Another amazing discovery the Webb telescope has made is smoke molecules in a distant galaxy. It's the first time such molecules have been discovered so far away from our planet. The galaxy in question lies 12.3 billion light-years away from Earth. It most likely formed about 1.5 billion years after the Big Bang. Despite such a huge distance between the galaxy and our planet, scientists have managed to detect chemical compounds found in soot or smoke, and it's quite a big deal since it has pushed the record for detecting similar complex molecules back by around 1 billion years. This study has also confirmed the sheer power of the coolest piece of space equipment of all time. It managed to make this discovery despite the fact that the spectrometer needed for the measurements didn't perform to the fullest after having experienced a sudden and surprising degradation. The James Webb Telescope has also helped to boost our understanding of exoplanets. Those are planets orbiting stars other than our own sun. At the beginning of 2023, the observatory spotted its first exoplanet, LHS 475b. It's located 41 light-years away from Earth and is approximately the same size as our planet. According to NASA, nowadays, James Webb is the only operating telescope capable of categorizing the atmosphere of Earth-sized exoplanets. The research team behind the discovery believes such results underline the precision of the telescope. They hope that it will help us locate many more rocky exoplanets that we might be able to colonize in the future. Even though, at first sight, it may seem that the universe is pretty empty, it's actually a very busy place, and Webb has all the necessary instruments to see all kinds of cosmic events happening out there. Just look at this image of WR 124. It's a star on the cusp of its explosive demise. In the image, the star is about to go supernova. It happens when a star runs out of its fuel and explodes at the end of its life cycle, releasing a giant cloud of space dust and hot gas into space. The star captured by the Webb telescope was at the Wolf-Rayet stage of its life. That's a period when a star is shedding its outer layers before going supernova. The next amazing thing discovered by James Webb is a star-planet hybrid with very strange clouds. This bizarre world, VHS 1256b, is actually a brown dwarf. Those are bigger than planets but too small to classify as stars. They emit some light of their own and are quite hot, but their mass is simply not enough to fuse hydrogen into helium like full-fledged stars do. Space bodies of this kind aren't actually brown. They occur in a wide variety of colors, but those are mostly invisible to the human eye. What we can see is the light they emit, and to us, it appears to be dark orange or magenta. The brown dwarf discovered by the Webb telescope is almost 20 times the size of Jupiter. It orbits 2 red dwarf stars, and to complete one orbit, it needs over 10,000 years. Astronomers first found out about this unusual exoplanet in 2016, but at that time, they didn't classify it as a brown dwarf, and, thus, couldn't explain its puzzling reddish glow. Now, thanks to the James Webb telescope, they know the space object's origin. Anyway, back to those clouds. As you know, clouds on Earth are made of water vapor. But those on the brown dwarf are different. They seem to be made of sand. It looks like good old sand from Earth, but it's actually not. The clouds are made of tiny particles of silicate. Another recent discovery involves several large galaxies that scientists believe were born not long after the Big Bang. They aren't supposed to be there, and no one expected to find them. But the James Webb Space Telescope has spotted them. These galaxies, as massive as our home Milky Way, are full of mature red stars. Astronomers have analyzed the light coming from them and estimated their age 500 to 700 million years after the Big Bang. It means that they came into being when our universe was very young, almost a baby. But the most bizarre thing about these galaxies is their tremendous size and the age of the stars dwelling there. The data received by the telescope don't coincide with the existing ideas about what the universe looked like and how it evolved in its early years. It also doesn't match the earlier observations made by Hubble. And here, James Webb has captured a distant region of space in unprecedented detail. This section of space is known as Pandora's cluster. In the image, you can see 3 massive clusters of galaxies coming together and forming a megacluster. The combined mass of these clusters acts as a powerful gravitational lens. And thanks to this natural magnification effect, scientists can see other galaxies in the region. Astronomers claim that the most recent image of Pandora's cluster is stronger and deeper than they have ever seen. James Webb has also managed to spot thousands of young stars never seen before in the Tarantula Nebula. This space formation got its nickname because of the appearance of dusty filaments spotted in previous images. It's the biggest star-forming region in the local group, which includes the galaxies nearest to the Milky Way. The Webb telescope's images have helped to shed light on the composition of the Tarantula Nebula. The telescope has also detected protostars, infant stars in the process of gaining mass. Astronomers expect that these protostars will eventually form and shape the nebula further. Among other discoveries made by the James Webb telescope, you can see the birth of 50 distant stars. Some of them power protoplanetary disks, which might later form solar systems light years away from our own. Here's one more image from James Webb. You can see a supermassive black hole that has a mass of 9 billion suns. It's so ginormous and ancient that scientists are struggling to explain its existence. Astronomers have also discovered a distant ring of dust, rock, and gas that contains a chemical called methylcation. It's known as a molecular building block of life, and it makes most of the organic material on our planet. James Webb helped researchers see powerful sandstorms on a planet 235 trillion miles away. Astronomers were happy to discover this treasure chest of countless tiny sand particles. Now look at this. Do you recognize this image? Those are the so-called pillars of creation. But this new view shows us just how star-speckled that dusty region actually is. You can compare the new photo with the one taken by Hubble in 2014. This is astonishing proof of scientific progress.
Earth's magnetic field hides a fascinating story. It turns out that it's getting weaker day by day. In fact, it's been doing so for the last 3,000 years. And if this trend continues, we could be in for some trouble within a millennium. What's the big deal? Well, picture this. Magnetic north becomes south, and vice versa. Pretty wild, right? When this happens, our planet's protective magnetic shield might weaken, allowing more cosmic rays to hit us. These high-energy particles from the universe can cause electronic malfunctions in our satellites and produce elements that could be harmful to us. The last time a polarity reversal occurred was between 772,000 and 774,000 years ago. Thankfully, humanity has some pretty smart people on the case who are investigating the history of Earth's magnetic field. They take cores of sediments from the seafloor and study the magnetization of fossils to figure out when these reversals occurred in the past and when they might happen again. Another group of researchers is studying the South Atlantic Anomaly, SAA, a vast region of Earth's magnetic field that is about 3 times weaker than the field at the poles. Using data from multiple satellites, they are trying to figure out what's causing the SAA and how it might change in the future. This could give us a glimpse into how a weakened magnetic field can affect our satellites and our planet. Sure, our generation won't be here to witness these changes, but it does make you wonder what that planet might look like upside down. Magnetically, that is. NASA's astronomers have also announced that in 4 billion years, the Milky Way galaxy is going to get a major glow-up. After a cosmic collision that will shake things up. I'm not talking about a small fender bender here. I'm talking about a titanic collision with our neighboring Andromeda galaxy. Humanity will have to hold on to its space helmet for this one, because the sun might get flung into a new region of the galaxy. However, our Earth and solar system probably won't be seriously affected. Sounds difficult to believe, so how come? NASA's Hubble Space Telescope did some hardcore measurements of Andromeda's motion. Although the galaxies will plow into each other, the stars inside each galaxy are so far apart that they won't collide with other stars during the encounter. However, the stars will be thrown into different orbits around their new galactic centers. According to simulations, our solar system will probably be tossed much farther from the galactic core than it is today. Set your telescopes aside. You don't need to start counting down the years. This event is likely scheduled in about 4 billion years, so chances for us to witness it are 0. Saturn is losing its rings. Thankfully, we won't be here to witness this sad event either. Apparently, the rings are being pulled into Saturn as a dusty rain of ice particles, all under the influence of Saturn's magnetic field. According to NASA's research, the ring rain is draining an amount of water products that could fill an Olympic-sized swimming pool from Saturn's rings every half an hour. The entire ring system will likely be gone in 300 million years. Scientists believe we should consider ourselves lucky to witness Saturn's ring system at all, as it seems to be in the middle of its lifetime. But if you think about it that way, that rings around planets are all temporary, there's a chance we've just missed out on the giant ring system of Jupiter, or those of Uranus and Neptune. These planets have only thin ringlets around them these days. Scientists have long debated whether Saturn was formed together with its rings or if the planet acquired them later in life. The new research favors the second scenario, indicating that they are unlikely to be older than 100 million years, while Saturn itself is around 4.5 billion years old. What caused the rings to appear in the first place? Well, there are a few theories. One of them suggests the rings could have formed when small, icy moons in orbit around Saturn collided. Perhaps their own orbits were messed up by a gravitational tug from a passing asteroid or comet. Who knows what humans might end up looking like in the future? It's unlikely we'll see any major changes in our lifetime. But let's take a journey to the future and ponder what we might evolve into. Will we become cyborgs with all sorts of cool machine implants? Or maybe we'll become a hybrid species of biological and artificial beings. To understand our future evolution, we gotta take a peek at our past. 1 million years ago, Homo sapiens didn't even exist. There were a few other similar species though, like the Neanderthal. Fast forward to today, and humans have become taller and sturdier. Maybe in the future we'll become smaller to conserve energy, as it's predicted that our planet will get more crowded. Speaking of crowded planets, living in these new conditions means we have to adapt, and fast. We're constantly interacting with lots of people, and remembering names is becoming a crucial skill. Luckily, technology might help us out with brain implants that will improve our memory. In the future, we might also have more noticeable technologies as part of our appearance. Imagine having an artificial eye with a camera that can read different frequencies of light. While predicting 1 million years into the future is pure speculation, we can use bioinformatics to make some predictions about the immediate future. Demographic trends suggest that urban areas will become more genetically diverse, while rural areas will become less diverse. And what about space? If we end up colonizing Mars, our bodies could change due to lower gravity. Maybe we'll have longer arms and legs, or even insulating body hair like our Neanderthal cousins. In the future, our moon is also going to witness some dramatic changes. We'll miss these ones too. In about 5 billion years, things are gonna get really interesting in this corner of the universe. For now, the sun is chilling in its main sequence phase, just burning hydrogen like nobody's business. In the future, during the red giant phase, the sun is gonna puff up like a balloon until its atmosphere reaches out and engulfs our beloved Earth and Moon. Our natural satellite, which is already moving away from Earth, is gonna get warped around the sun's influence. Its orbit will get all wonky, and it'll end up closer to Earth during the new moon phase than during the full moon. And that's not even the worst part. If left alone, the moon would keep on moving away from Earth until it'll need almost 50 days to orbit us. As the Sun continues with its own journey, its atmosphere will drag on the Moon and cause its orbit to decay. Eventually, the Moon will get torn apart into a stunning ring of debris circling Earth. We're talking about all its mountains, craters, and even the footprints and flags we left there, all scattered throughout the debris field. There's a chance the Sun will shed enough mass to spare Earth and the Moon from total annihilation. Or if we're really lucky, the Sun will lose 20% of its mass and we'll be safe and sound. It's all just theory right now. We haven't seen a red giant star during this phase. The universe itself might go completely dark one day too. Scientists can't predict it with absolute certainty, but they can make some educated guesses. Right now, our universe is 13.77 billion years old, and it's still churning out new stars left and right. It's said that eventually, after about 1 trillion years, the last star will be born. That final star will be a little guy, a red dwarf, just a fraction the size of our Sun. These stars are champs at living long lives, slowly sipping on hydrogen to keep their fusion reactions going. But even they can't last forever. Fast forward about 100 trillion years, and the last light will go out. The universe will be dark and lonely, but thankfully, we won't be here to watch it all fade away.
At the edge of our solar system, there's a cold and mysterious region known as the Oort cloud. It's a hypothetical vast area of icy space objects surrounding the Sun. It's believed to lie far, far away from our star, from 2,000 to 5,000 astronomical units. For comparison, Pluto's orbit carries the planet between 30 and 50 astronomical units from the Sun. And there, in this freezing emptiness, a rogue planet may be hiding right at the moment. At least, that's what new research has recently suggested. Rogue planets are called this way because they don't orbit around any star. They wander the galaxy alone, totally untethered. Without stars, they don't have days or nights, only eternal darkness. Rogue planets are usually kicked out of their planetary